Yes, good morning, all of you. Good morning, everyone. Respect.
Good morning,
Good
sir.
morning. Good morning, sir.
Good morning. Yes, good morning, all of you. Good morning, everyone. Respected professors.
Good morning, sir.
Good morning. Yes, good morning, all of you. Good morning, everyone. Respected professors.
Good morning, sir.
Good morning. Yes, good morning, all of you. Respected professors, dear colleagues, and my dear friends. We are all here to witness the flagship annual international conference of the Council International Conference. That's IEEE INDICON 2020. And here with us is the country's leading authority of natural language processing, Professor Dr. Jitendra Kumar R. Saini, a highly accomplished researcher, distinguished and established academician and administrator. Professor Saini is at the forefront of his research areas, namely natural language processing, web mining, machine learning, and data analysis. With more than 150 research articles in various research publications, including IEEE Elsevier, ACM Taylor and Francis Springer InterScience. His research works have been cited in more than 40 countries all over the world, including prestigious international journals with Thomson Reuters impact factors like 8.746, 7.596, and 3.928. Moreover, Professor Dr. Jitendra Kumar R. Saini has been thrice awarded with Outstanding Reviewer certificate by Thomson Reuters Impact Factor Bearing International Journal and has been named among the top 1% and also in the top 50 computer science reviewers in the world. He is a recipient of prestigious DART Fellowship from Germany and research project from Israel. Moreover, Professor Sani has been a fellow, life member, and executive committee member at chapters of various professional bodies like IET, CSI, ISG, ISTE, ISRS, and ISCA. Is a passionate knowledge seeker, Professor Sani's quest for knowledge can be well justified by certificates from more than 2 dozens of massive open online courses from prestigious universities like MIT, Stanford University, Johns Hopkins University, Rice University, to name a few. Now, in the role of academician and an administrator, so Professor Sani is currently leading Symbiosis Institute of Computer Science and Research, Pune, as the director of the institute. Prior to joining SICSR, Professor Sani was working as a state government university endorsed professor and director. Talking about his vast experience, he has been the head of the department, university coordinator, zonal exam coordinator, AP Innovation Circle of entire South Gujarat under the state government's Gujarat Technology University. Also being a university topper and gold medalist for all the 3 years of his MCA degree, he had the opportunities to work alongside Gujarat Secretariat, Gandhinagar, on an ambitious e-governance project of Government of Gujarat back in 2005, as well as with one of the only 4 licensed certifying authorities under Ministry of Information Technology, Government of India. Now, since 2012, Professor Sani has been included in the Marcus Who's Who in the World USA. His lectures are broadcasted nationwide and available online as a part of NCTEL. Moreover, Professor Sani is an IBM certified database associate and associate developer with various other certifications under his belt. Sir, it's a great pleasure and honor to welcome Professor Dr. Jitendra Kumar R. Sani to deliver his speech on the topic Natural Language Processing for Indian Languages. Sir, please grace the session by your words. Thank you.
A very good morning to all of you, the dignitaries who have joined for the inauguration session. And in fact, it is indeed a pleasure, a matter of pleasure for me as well to talk about natural language processing, which is an area which is very close to my heart, and I have been working in this area since almost 15 years. I have delivered talks on this topic both in India and abroad. I mean, countless number of times, and many more are scheduled in coming days also. So without any further ado, I will directly switch on to my presentation. Is my presentation visible?
Yes, sir, it is.
Yes, sir.
Okay. So while I will be presenting on NLP for Indian languages, I will not be observing and monitoring the chat box. So if at all there are any questions, I will take it all together later on. And thanks to Shar for that introduction. I don't think that it could have been presented better. In fact, it was like I was not feeling that I have achieved so much, but based on your presentation, now I am getting that feeling. So thanks for that excellent presentation. Because
Thank
from
you, sir.
perspective of because from perspective of natural language processing, this is also a skill, and in a way it becomes an area of natural language processing itself. So as he said, I am working as professor and director at Symbiosis International Deemed University's SICSR, which is in Pune, and he has already given a very nice introduction, so I will skip this slide altogether. So just to confirm, are my slides visible?
Yes,
Yes,
sir.
sir. Sir, visible.
Yes, sir.
Okay.
Yes, sir.
So before I start talking on the area of natural language processing, there is a disclaimer because there will be many things that I will be discussing, and they might be related with the regions, religions, but if at all there is any association with any person or any region or religion and so on, it will be just pure coincidence. This presentation is just meant for academic and research purposes only. And there are many points even which you might not find through Google search or Wikipedia also, because I have included those points based on my experience since all of these years. And before I proceed further, let me also tell you that as part of my presentation, I will be using different languages. So, and in fact, I will be using like examples from Marathi, German, Punjabi, Hindi, Gujarati, Sanskrit, and so on. And all of these are the areas where there are many candidates who have completed their PhDs under my guidance. So just to give you the glimpse of what is actually working in the real world, I will be taking the examples from all of these languages. So this will be the agenda for today's discussion. I will start with introduction, then move on to history of NLP. Then I will talk about pre-processing in NLP, then NLP areas and tasks. And I will be discussing the parlance of the area of NLP, wherein I will be discussing about many terms which are not even known to. I have seen many persons who have completed their PhD in this area and they are not sure. I mean, like, what is difference between term and token? What is difference between language and script, and what is the difference between speech and dialect, and so on and so forth. And in fact, I have observed that these terms like tokens, types, and terms and words, all of these are used interchangeably. So I will be discussing about it, like what is the difference. And finally, I will be giving you a glimpse of challenges in the area of NLP. So I start my presentation formally with what is language. Language is something that can be used for communication. For example, now I am speaking and you are listening. So basically I am using one language. So language in general is anything that can be used for communication. And then there are different types of languages. For example, there is sign language. So if I do some gestures and if someone can understand, then it is also a language. I have seen many people who say and who believe that sign language is not a language and it cannot be considered as part of NLP. This statement is not correct. For instance, if I say like this, rather if I do a gesture like this, so basically it indicates namaste or namaskar. So I am communicating something and you are able to understand that, okay, I am greeting you. So as I said, that language is something which can be used for communication. Therefore, sign language is also a type of language. Not only that it is a type of language, it is also a natural language and it can be very well used as part of NLP. And on the sidelines, I will also keep on telling you which are the open research areas. So this is also one of the open research areas. I mean, you will find many people who have worked on languages like Punjabi, Hindi, Spanish, French, and so on. But only a little research work has been done as far as sign language is concerned. I can remember the research work of Dr. Vishal Goyal, who has been quite actively, Dr. Lalit Goyal and Dr. Vishal Goyal, who are quite active in this area of sign language. Then there is something called extinct language. So extinct language is a language where we do not have any speakers of that language. For example, Go is an extinct language, Coda is an extinct language, and then there are many other extinct languages also. And I will continue this discussion along with another term called dead language. So dead language is a language where we do not have any native speakers. So the difference between extinct language and dead language is that for extinct language, we do not have any speakers, absolutely no speakers. And for dead language, we do not have any native speakers. So example of dead language is Latin. So that means to say that we do have some speakers of Latin, but Latin does not happen to be their native language. And a very controversial language in this context can be considered Sanskrit, which is an Indian language. And if you go through the title of this presentation, it says natural language processing for Indian languages. So I will be, focusing a bit more as far as the Indian languages are concerned. So Sanskrit happens to be a bit controversial in this context because you will find many people discussing about it. You will find many blogs and many people talking about it, that Sanskrit is a dead language. And then you will have another group, another school of thought who will say that no, Sanskrit cannot be dead language. Sanskrit is a language that we are using daily. I mean, if we are praying in the marriage ceremonies, and every now and then we are using Sanskrit. Even if you see the logo of NSUT, your own institution, it has one sentence that says Ano Vidraha Tatvo Yanto Vishvataha, which basically comes from Rig Veda. Or even if you think about Symbiosis International Deemed University, that means my university, we have Vasudhaiv Kutumbakam. So basically it is Sanskrit only. So in fact, this is the reason that, okay, then we have the Agni missile and the Prithvi missile. So Sanskrit has been in use, undoubtedly. But technically speaking, we will have to accept it and we will have to understand this, that Sanskrit is actually a dead language if we go by the definition of a dead language. I can understand that there may be one group of people and who may feel and who may argue that no, how can you say that Sanskrit is a dead language? But if we go by the definition of dead language, then it says that a language which does not have native speakers. And if you, I mean, go through all the research papers, all the text which is written in this area, Wikipedia, and the government records, so you will have to accept it that Sanskrit is a dead language unless government comes up with some initiative, or unless there is a sort of public interest litigation, or so on and so forth, which claims, because there have been some people in villages of Karnataka and remote locations in Odisha as well, where people say that Sanskrit is actually their native language, but it is not on record. So unless it is on record, we will have to accept it that we do have speakers of Sanskrit, but we do not have speakers who can say that Sanskrit is their native language, who can say that Sanskrit is their mother tongue, for example. And in fact, this mother tongue is a very generic term when it comes to NLP. When we say mother tongue, it could be the mother tongue or it could be literally the father tongue as well. So basically, in general, from NLP perspective, we say that it has to be a parent tongue. Then we can say that it is a native language. And if it is a native language, then it is not dead. So that is all about the dead languages. And in fact, for any language, it first becomes a dead language. And then only it goes to the status of extinct language. So in other words, you can say that first, there are no native speakers for a particular language, and then there are no speakers at all for a particular language. And recently, there was one more language which was listed in the list of extinct languages, and that language is from India itself. That happened in April 2020. And particularly for a country like India, which is one of the 7 countries in world let me share this on the sidelines. India happens to be one of the 7 countries in the world which are very rich as far as the languages are concerned, as far as the variations in languages are concerned. And this, on one side, may make one feel happy that, okay, we are living in a region which is very rich in the languages, but on the other side, we also need to focus on the fact that it is also one of the countries where the number of extinct languages and the number of dead languages is maximum. Because when you have so many languages and given this globalization and the way English is taking over all other languages, so naturally the probability of the existing languages becoming extinct and dead becomes more. As far as Sanskrit is concerned, let me also tell you that it is included. I don't know, and I really wonder how many of you know about it. But Sanskrit also happens to be one of the 23 languages, which is the constitution. So as far as such steps and measures are concerned, government is also taking some initiatives. And in fact, it also happens to be one of the languages which is revived. So you have 20 odd languages internationally in world which are in the process of revival, and Sanskrit happens to be one of those languages which are revived. So this is all about extinct languages and dead languages, and I will definitely try to motivate you, and I will definitely pursue that if you are interested in working in the area for natural language processing, you can choose one of the extinct languages, you can choose one of the dead languages, and or you can choose your mother tongue also. I mean, just look at this. If it comes to English, and if I ask how many letters are there in the English alphabet, all of you may probably immediately say that, okay, it is 26. But if I say how many letters are there in the Punjabi alphabet, and how many of them are in Hindi, and what about Sanskrit, what about Marathi, what about the other Indian languages, I don't think that people will be able to answer it quickly. And if I say how many vowels are there, you will immediately say 5, okay, A, E, I, O, U. But if I say how many swar are there in Hindi or Sanskrit, or for that matter, any other language, it could be Punjabi, could be your mother tongue, could be Malayalam, could be Telugu, could be any other language. So, so basically, the point that I'm trying to emphasize is that when it comes to Indian languages, when it comes to one's own mother tongue also, I have seen that people are not working in these areas. And in fact, this is the reason why these languages are called low resource languages. Low resource languages means you do not have much resources, you do not have corpus, you do not have data about those languages, you do not have the spoken text, you do not have the written text, you do not have the text in the digital format so that it can be used for the machine learning algorithms. So this is all about extinct languages and dead languages. Moving further, we have something called isolate language. For example, BAS, which is an isolate language. So in order to understand the concept of isolate language, we need to understand the concept of language families. We have language families like we have Afro-Asian language family, we have Sino-Tibetan language family, we have Indo-European language family. In fact, Indo-European language family happens to be the biggest language family, the primary language family of world. So I am discussing this from both perspectives, from the international perspective as well as from the national perspective. So Indo-European language family, I am using this word family because it does not just consist of one language. It has multiple languages. So it is like the typical genealogical structure, the tree structure. So Indo-European language family happens to be the biggest one. And one of the branches of Indo-European language families is Indo-Iranian languages. And obviously, then you have other branches like you have Germanic, you have Hellenic, you have Italic, and so on and so forth. But when it comes to Indo-Iranian language family, which is basically child of Indo-European, then further you have 3 categories. One is the Iranian family, which includes languages like Kurdish and other languages which are spoken mostly in the Gulf countries. And then you have the Indo-Aryan language family, which is also called the Indic language family, which includes mostly all of the Indian languages. And then you have Nuristani, which is another branch, in fact, which is the 3rd branch of Indo-Iranian language family. And basically, it includes a few languages which are spoken in some regions of Afghanistan. And when we come to the Indic language family, when we come to the Indo-Aryan language family, Dravidian languages, which earlier were included as part of this language family, And as on date, they are not included as part of this language family, and Dravidian languages are treated like a full-fledged language family in itself, along with Indo-European and Sino-Tibetan and Afro-Asian and other language families. So basically, Dravidian languages include most of the languages of the southern India, as well as the countries like Indonesia and Sri Lanka and the other countries in the southeastern Asia. So coming to the Indic branch and coming to the Indo-Aryan branch, we have languages like Punjabi, Hindi, Saraiki or Multani, and we have Marathi, Gujarati, and so on and so forth. So as I said, that most of the Indian languages are included, except the South Indian languages. Mostly the East, West, and North Indian languages, including the Pahadi language and so on, they are included in the Indic branch. So basically, this is the concept of language families. And so typically we have grandparent, we have child, and we have grandchild, and so on. So there are a few languages which cannot fit in any language family. So those languages are called isolate languages. So this is just to give you the idea of the concept of isolate languages, so that in future, if you come across this term isolate language, you should know that it is related with the concept of language families. Okay, moving further. So all of these languages, be it sign language, be it extinct language, be it dead language, be it isolate language, and obviously this list is not exhaustive, because then you can think of endangered languages, then you can think of constructed languages, then you can think of transparent languages, and so on. But the list that I have discussed, sign, extinct, dead, and isolate languages, all of these are natural languages. And why I am emphasizing on this word natural is because this presentation is basically on NLP. So NLP means natural language processing. So first we try to understand what is the concept of language, something that can be used for communication. And then we came to the concept of natural language. So natural language is a language, that means it is a mechanism that can be used for communication in a natural way, in a natural flow. It is not artificial, it is not synthetic. For example, if we talk about C programming language or C++ or Java, or for that matter Python or R or any other programming language, all these programming languages as an analogy could be called artificial languages or the programming languages. So this is about language and natural language. Okay, now let us have a look at the history of NLP. I mean, if you have to talk about the area of natural language processing or the history of NLP, I can speak for centuries and centuries, and still I will have something to say, but the time will fall short. But for the time being, let us discuss in brief about the history of NLP. So this is the timeline that I have created, and it is not calibrated to the precise scale. But roughly, if you see, we are in this period, approximately our life is in this range, roughly from 1950 to 2050 or up to 2100. This may include me, this may include all of the students, this may include your professors. So roughly this is the range. This is a rough range only. And the discussion that we are having today is in this overlap area. This may sound a bit philosophical, but the fact is that when we are discussing this topic in December 2020, so we are discussing this topic based on the data and based on the research, based on the technological advancements which are available as on date. So if you ask me to give this presentation tomorrow, it may change. If you might have asked me to give this presentation yesterday or day before yesterday, then again the data might have been different. And in fact, this is the reason. So if you might have observed that on my first slide, I have written that this is the fourth version of this presentation. But this overlap period of 2020 on the general timeline as well as in the timeline of our lives is the one where we are discussing this topic, and based on the content data that is available on date. And as far as history of NLP is concerned, typically you cannot specifically distinguish the development of natural language processing and the development of artificial intelligence. And as such, you can see that this concept, I mean, the concept of natural language processing used to exist even in the 14th and 15th century. where the philosophers like Descartes used to say that from one language to other language, conversion is just like using the code of the other language. It is like encrypted language. And it specifically came into limelight with the very famous Turing experiment. Basically, it is called Turing test, or the game, or the imitation game, which was basically an experiment performed by a person called Alan Turing. So what he did was, like, there were three rooms. In one room there was a machine. In the other room there was a human being, and the third person was supposed to identify which one of these two rooms is a machine or a human being. And the only mode of communication was text, and obviously the machine or the human being in the other room were not visible to this third person. And if this third person or the judge can identify that, okay, in room one we have a machine or human being, or in room two we have a machine or human being, then it can be said that the machines have acquired artificial intelligence. So, in a way, this is not just an experiment of artificial intelligence, this is also an experiment of natural language processing, because in a way, when you are communicating with a machine, or when you are communicating with a human being, basically the mode of communication that you are using is a natural language. The mode of communication that you are using is a language, and not just any other language, because here we are not using any other programming language. Here we are using natural language. Therefore, in a way, we can say that the natural language was the concept of natural language processing was born in the 50s. And in fact, if you go by the typical general philosophy, we have two schools of thought. One is rationalist and the other one is empiricist. And why I am discussing these two schools of thought, has been a lot of influence of these schools of thoughts in the area of natural language processing, as well as in the area of artificial intelligence also. So the rationalist school of thought says that, for example, how do we learn languages? When a child is born, child does not have any know-how of language. This is what we believe as on date. I will just trigger your mind. I will not tell you, okay, what is my stand. I will leave it up to you to decide what is your stand. But I will explain both of these schools of thoughts, and then you can decide it for yourself. Would you like to go with the rational approach, or would you like to go with the empiricist approach? So the rationalist approach says that when a child is born, then as part of the genetic structure, as part of the information which is sort of hard-coded in the brain of the child itself, it is, so that information is already built in when a child is born. And which information I am talking about? I am talking about the information about the languages. So the rationalist approach says that a child does not learn a language when the child grows and listens to that language. For example, the mother tongue might be listening to mother or father or grandparents and so on. So the rationalist approach says that this is inbuilt. And the empiricist approach says that when a child is born, it is like tabula rasa, which is which basically comes from Latin, and it means that the child is completely blank, and nothing is innate, nothing is inbuilt, nothing is hard coded in the brain of the child at the time of birth of a child. So the empiricist approach says that a child, as the child grows, it has some experiences, and based on those experiences, a child learns about a language. And this is how the child acquires the grammatical information about a language, and then slowly starts to speak that language. And this is how the child learns that language. So if we see from the perspective of history of NLP, the period before, I mean, like this is 21st century. So before the 20th century, it was empiricist approach, because everyone used to believe that nothing is built in. Child is born blank, and then the child learns the language as the child grows. And then approximately in the mid 50s, and this is again a sort of coincidence that the Turing test experiment happened in the 50s, and then we have a person called Noam Chomsky. You might have heard his name, because He is sort of living legend when it comes to the area of linguistics. So he said that basically he was a protagonist of the rationalist approach. So he said that no, the child does not learn a language based on the experiences. That language is inbuilt in the brain of the child at the time of birth itself. So he was the American linguistic and American philosopher. So this entire duration of 50s, 60s, based on his research work and based on many books that he has written, and we have the concept of Chomskyan grammar and whatnot. So basically, this entire period was literally dominated by his philosophy. And this was the duration when people used to believe that no, rationalist approach is correct. And a child cannot learn a language, but it is built in. Obviously, when we say built in, I mean, when it comes to rationalist and empiricist approach, there is no absolute difference, but there is a difference of degree. This is a bit philosophical discussion, but I will tell you why I am discussing when I will be going to the next slide. So basically, the point is that this period of 50s, 60s, and 70s was dominated by this concept of rationalist approach. And then after 80s, and in fact, starting the early 80s, slowly people started to use these statistical techniques. And then people used to say that no, it is not possible that all of this information is built in. And a child at the time of birth itself knows all of those languages. And then it acquires little bit of experience and then starts speaking that language. And then there are various arguments in favor and in opposition of both of these approaches. But one very famous example is like if a child, let us say, whose mother language is, let us say, Hindi, for example, and if that child is, brought up in an environment where all of people are speaking some other language, let us say French, then actually the child will start speaking French. So basically that confirms the empiricist approach. And then you have various other concepts also. For example, the concept of a color, which the rationalists say that how can it be learned? So that is why I said that there are arguments in favor as well as in opposition of both of these approaches. And as I said earlier, I will leave it up to you to either go for the rationalist approach or to go with the empiricist approach. But as far as the history of NLP is concerned, so earlier there were people who used to believe in the rationalist approach. Then people, I mean, before 500, 600 years, then people used to believe in the empiricist approach. Then particularly in the last century, in the middle part, 50s, 60s, people used to believe in the rationalist approach because that was the period which was dominated by rationalists, particularly Noam Chomsky. And then 80s and onwards, people used to say no, that empiricist approach is the one which is actually correct. And now I will tell you why I discussed about rationalist approach and empiricist approach. Because both of these schools of thought have a direct relation, not only just with natural language processing, but also with artificial intelligence. But my focus will be more on NLP because that is the main area of discussion for us today. So from NLP perspective, and as far as the history of NLP is concerned, we have three approaches. I will begin with two. Number one, symbolic, and number two, non-symbolic. So basically, the symbolic approach comes from the school of thought of the rationalists, and the non-symbolic approach basically comes from the school of thought of empiricists. The symbolic approach says, and the symbolic approach is typically also called good old-fashioned artificial intelligence. I really wonder whether you have heard of that term or not, GOFAI, and it's called the classical approach. So that approach says that whatever we see in this real world, whatever we can see, whatever we can touch, all of these are entities and they can be sort of coded as symbols from a computational perspective. And then you can have some operations. For example, if I say Jatinder Saini is one entity, Dr. Saini is one entity, and this laptop is another entity. And then you have relations between these symbols. For example, Dr. Saini is being recorded through a laptop. So you have entities basically which are symbols, Rather, I will say this way: you have entities put as symbols, and then you have relations among those entities, which may be in the form of adjectives, which may be in the form of verbs, and so on and so forth. So I am not going in that much detail as far as the symbolic NLP is concerned. But the point here is that the symbolic approach basically derives from the rationalist school of thought, which says that you have some symbols, you have some relations among those symbols, and then you can process it. And this is the way you can process any natural language. And this was the approach which was quite prevalent in that period, which was dominated by the Chomsky thoughts, as I said, in the 50s, 60s, and so on. But starting with the 80s, suddenly came this concept where people started to think that instead of feeding a limited amount of data to a machine, so that is why I said that this is an area where you have an overlap of artificial intelligence as well as natural language processing. So in the early 80s, people started to say that instead of giving a limited limited data to a machine to learn about something, why not give it a lot of data and let the machine decide for itself which patterns to learn? And this is where the non-symbolic approach came into picture. And this was also the time where the statistical approaches crept in. Because when you have a lot of data and when you do not have clear-cut rules about those data, okay, this leads me to one more point. The symbolic approach is typically rule-based. Rule-based in the sense you have if-else ladder, you have switch cases, and the machine will simply go through those if-else cases, and then it will give you the output. And basically, this is sort of what happened with the Turing experiment as well. And then there was opposition also for the Turing experiment, even though it has been much criticized and it is sort of controversial also. But one thing is for sure that it basically is a very important concept as far as the area of AI and NLP is concerned. In fact, this reminds me of one more very famous experiment, John Searle. It is called Chinese room experiment. So basically, John said that the Turing machine experiment cannot be called to be a true experiment of artificial intelligence, and we cannot say that the machine is truly intelligent, even if the judge cannot identify which one is machine and which one is human being. He said that to actually call a machine artificially intelligent, the machine needs to understand a language. But here what is happening is you have those if-else cases. So if I ask a machine, what is your name? It will go through its database sort of dictionary approach. It will find the answer and then it will give the reply. But it is not understanding what you are asking. So understanding is at a higher level. So John said that it cannot be called to be an intelligent machine, and that is where came the concept of narrow artificial intelligence, weak artificial intelligence, and strong artificial intelligence. So John Searle said that the machine cannot be called artificial intelligence because it is not understanding. It is just simulating. So when we talk about the rule-based approach, when we talk about the symbolic approach, it is actually just simulating the artificial intelligence. It is not actually intelligent. And something which is actually intelligent can be called the artificial general intelligence, the specialized area. For example, if you are interacting with Cortana, if you are interacting with Alexa, if you are interacting with Siri, if you are interacting with any of those things, because this is also a part of NLP. If you're interacting with all of these devices, then even though they are using artificial intelligence, but they are not intelligent. So basically, they just scan the information which has been fed to them, and then they accordingly reply. They are not intelligent. So basically, they are simulating the intelligence. So in a way, it is also weak artificial intelligence. General artificial intelligence will be the one which actually understands what human beings do and say and behave like the human beings. And then moving on the same lines, we have the concept of super artificial intelligence also. So that is the area where people say that the robots will take over the human beings. So that is the third stage. Okay, fine. So coming back to our discussion of symbolic, which is rule based, then to non-symbolic, which is not rule-based, but it is based on statistics. So you have a lot of data, you are feeding that data, and then the machine itself is trying to find the patterns from that lot of data. And see, there is one more reason, and it is a very beautiful concept. When you move from symbolic to non-symbolic approach, basically you also have keep into consideration the fact that when we moved from 50s to 80s, there was a reduction in the cost of storage, and there was a increase in the processing power also. So both of these things, you can think of the Moore's law. So both the processing power increased. So both of these things in a way contributed to proliferation of non-symbolic approach. And how is it related with the rationalist and empiricist approach is, see, basically rationalists say that everything is innate, it is built in. So that is what symbolic approach did. There were some rules and everything is coded. So that is why it is rationalist approach. Empiricist approach says that you have to learn. You have to observe, you have to do an experiment, and then you have to learn from that experiment. So when we are feeding a lot of data to a machine, and when the machine itself is finding the patterns from that data, so that is non-symbolic approach. And non-symbolic approach can further be divided into two categories. And number one is statistical approach, and number two, the deep learning approaches that we are using today. Because in case of statistical approach, you know, it was like sort of transition from rule-based to pattern finding. But when it comes to deep learning, because even for case of statistical approaches also, you know, you have to deal with feature engineering and so on, which is hell of an effort. But when it comes to deep learning, you have to just give a lot of data to a machine, and then the machine itself learns the patterns. Obviously, then it uses various statistical techniques also in the background. So that is where the deep learning came into picture when it comes to NLP. And this was the period sort of like the first decade of this 21st century itself. So this is the entire history of NLP. But I think my discussion on history of NLP from rationalist to empiricist schools of thoughts, from symbolic to non-symbolic, will be incomplete if I am not discussing what is happening as on date. So you might be overwhelmed with the discussion of symbolic, and you can understand that, okay, it was not that promising, and then came the concept of statistical NLP. Even that was not that promising, and then came the concept of deep learning. But see, what is happening is we have like pros and cons of both the approaches. I will not say that the symbolic approach is completely bad and the deep learning approach is completely good. And I have strong reasons behind this, and you will agree. See, when it comes to the symbolic approach, everything is hard-coded. So you have rules. And when you are coding those rules, you are clear with what you are doing and with what you are expecting. So if you give some input, you can predict that, okay, this should be the output because you have coded it. So the process is completely transparent. But when it comes to the non-symbolic approach, particularly from statistical to deep learning approaches, you are just feeding a lot of data to the machine. You are just, dumping the data on the machine, and then the machine is itself learning from the patterns. But you don't know what are the patterns and how did it find those patterns. So the entire process remains like a black box. It is completely, you can get the output. If you are getting the output as expected, it is fine. Otherwise, you can go for multiple epochs and multiple iterations and so on and so forth. But the entire process remains like a black box to the end user. And the second difference or sort of disadvantage when it comes to the deep learning approaches is that you need a lot of data and you need a lot of processing power also. So because of these three reasons, we have something called neurosymbolic approaches. So what neurosymbolic approaches do is like they merge the best of both of the worlds, from the symbolic approach also and from the non-symbolic approach also. So you have a lot of data, as we do in case of statistical and particularly the deep learning approaches, and then you have some hard-coded rules also. So basically what is happening is if you are getting some output, at least it will be closer to what you are expecting. And this is also the area where, the concept of explainable AI is coming into picture. I really wonder whether you have heard of that term or not. But basically, explainable AI is also based on this idea. So, symbolic approaches are the one that are in use today. And when I say today, I do not intend to say that neurosymbolic approaches are used or their use has started in the year 2020 itself. Uh, I think since last 10 years or even more than that, in fact, these approaches have been used. And why I am emphasizing on neurosymbolic approaches is because if you remember in one of my previous slides, I was just trying to demonstrate that the timeline and the life timeline and then the overlap period. So this is the time when we are using neurosymbolic approaches, and it is the order of the day. Having said so, let me also add, in fact, I should ask this question, that which is the best approach then? Is it symbolic, which is completely transparent? You know what will be the output, less processing power is required, and or is it non-symbolic? Either the statistical or the deep learning approach, you get the desired output, may not be exactly matching with what you are expecting. You may not know how the machine is giving that output, and you may not be able to tweak it. You may not be able to fine tune it, except with those experimental parameters that we use for deep learning. Or will you use the neurosymbolic approach, which combines the best of both of these worlds? See, I will not expect a specific answer from you. You just have to answer it for your own, either symbolic or not symbolic or neurosymbolic. But if you ask that question to me, I will say that it is none of these, because it simply depends. You can't just fix it. You can't say that, okay, it has to be symbolic or it has to be neurosymbolic or it has to be not symbolic. It just depends. It just depends on the functionality we did. It just depends on the need of the task. So if you want to do a particular task and if you feel that, okay, let me give you another example. So if you know that this domain is very specific, it is clearly known to me, and I can code all the rules exhaustively without making it too intricate, then obviously the symbolic approach is the best. But if it is not possible, then you should go for non-symbolic. And if you feel that the efficiency, accuracy, because typically either it is artificial intelligence or it is natural language processing, or if it is machine translation, you go to blue score. Otherwise, you go for accuracy, efficiency, precision, recall, the confusion metrics. And whichever approach gives you the best result, you should that approach. So you can't say that it is absolutely symbolic or absolutely non-symbolic or absolutely neurosymbolic. It just depends. Okay, so now I will be discussing in brief about the pre-processing steps in NLP. Before I proceed, let me just confirm, because I have been speaking for almost an hour now. Are you with me? Can anyone confirm?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. So I will be discussing a bit about pre-processing in NLP. First of all, there is something called casing. Casing means you have to make sure that the case is same. So either the entire text is in lowercase or the entire text is in uppercase. So that deals with casing. See, this particular slide is too generic. Say that you have to go for casing, or when you have to go for this, or when you have to go for that. It does not necessarily mean that you have to apply all of these processing steps in whatever project or whatever research or whatever application that you are designing. It again just depends. It depends on the need. So if you are working on sentiment analysis, your need could be different. If you are working on machine translation, your need could be different, and so on. So then you have to take care of emoticons, emojis, stickers, and smileys. Particularly, these things come into picture when you have to, process the text. See, now I will be multiple times using that term, process the text, because we are talking about natural language processing. So whatever is written in tweets, whatever messages you are receiving through WhatsApp or blogs are there. So you have to take care of emoticons, emojis. Okay, let me tell you the difference in among these four. Emoticons means it is text only format. Just a moment. Let me see if I can use a pen. So something of this sort. Are you able to see this? Are you able to see this?
Yes, sir.
So this is basically emoticon. So basically emoticons were used in the text-only environment. And then you have emojis, which is like sort of my drawing might not be very good, but just to give you an idea. So this is emoji. And then you have the concept of stickers, which has recently come up, which may have some animations also. And basically, all of these are collectively smileys. So smiley is like anything which is indicating some emotion. Could be happy, could be sad. So all of these are smileys. Smileys does not necessarily mean that it has to be, happy mood only. Okay. So moving further, we have the concept of treating words of different types, and then I have this entire list. You may need to specifically treat the frequent words depending on your requirement. You may be either continuing with those words which are having maximum frequency, or you may need to completely discard them. So that is why I said that it just depends on what you want to do, what you intend to do, what is your final expected result. You need to take care of hyphenated words. You need to take care of misspelled words. See, when it comes to natural language, and in fact, all of these sometimes become challenging also. Because when people write or tweets and other things, then there are many misspelled words also. And I have dedicated one slide which I will be discussing towards the end of this presentation. In fact, it is going to be the last slide. Then you need to take care of accented words. You may have some accents like this. And you need to take care of abbreviated words. You need to take care of rare words. So depending on your application, rare words could be actually the most important ones. You need to take care of stop words. For example, a, the, in, of, is, here, there. These words may not have much relevance when it comes to machine learning algorithms. And in fact, it is said that when you search something on Google, um, even if you are not using those words, because in any case, Google's algorithms are going to ignore it. It is just wastage of time. So it is always advisable not to use them. So these type of words are called stop words. And then you need to take care of length of the word. If your word is, let us say, having a length of 100 characters, then your algorithm should basically discard it, because it may not be the expected word. And it depends on the language also, because when I was in Germany, you have words like which are having 46 characters, 50 characters also. So then it also depends on the language. So not just the area, the functionality, the domain, it also depends on the language. And then if you are fetching that data from web, which generally we do most of the time, then you need to take care of HTML and URL tags, because they are going to be of no relevance as far as the experiment are concerned and the processing of natural language is concerned. So you may typically have those TR, TD, table, HR, BR, and so on tags, including SPTP and so on. Then you need to take care of OOV. OOV means out of vocabulary words, words which are not part of the vocabulary, because these words may not be relevant to your research work. Then you need to take care of apostrophe words. For example, boy, apostrophe s, boys. So possessive form. So again, it depends on your application. Is there any relevance or not? And then you need to take care of noise words also. Basically, it is also a type of stop words. See, you will find that there is an overlap among these terms, because different researchers treat different type of words differently. When I was doing a PhD in NLP in the year 2005, for me, noise words were a type of stop words. And because stop words means anything that we need to remove. And an example of noise word would be like A, S, F, and K. So it is not a dictionary word. If I am using English language, because in NLP you have to be specific. For some other language, it may have some relevance. So basically, it is a noise word and it needs to be removed. And then you may have some missing values. For that, you may use the concept of text imputation. Missing values, null values, not available values. Then there might be some irrelevant characters sort of junk characters or machine characters which may not be relevant to your research. Then you need to specifically think about numbers. For example, if there is a tweet that it happened in 2020, then the number may be important. Or see, it again depends on the application. Why I am processing that text? Could be phone number, could be year. So if you have that entire document, and if you need to let us say go for named entity recognition, like find the name of the person, the birthplace of the person, the birth year of the person. In that case, numbers may be relevant, but otherwise, numbers may not be relevant. So you need to decide. You need to take a stand whether I will consider the numbers for my project or not. Then what about the punctuation marks? So as I said earlier, also apostrophe, for example, it is also a part of punctuation. And then others include exclamation mark, question mark. Are you going to treat the interrogative, I mean the questions or the exclamatory statements separately? Is there any relevance based on your research work? So you need to think about it. And then the special characters, again, as I said, for irrelevant characters also. And the irrelevant characters are like machine characters, which are not having any relevance. And the special, like the sign of dollar, the sign of rupee, the sign of yen, not just necessarily for currencies, but the other signs like hashtag, percentage sign, and so on. And then you need to take care about white spaces also. And it again depends on which language you are using. For example, for Burmese language, there are no white spaces. In fact, in the modern Burmese language, because I have done some research work in Burmese also, in the modern Burmese language, which is language of Myanmar or Burma, now they are using these space characters, but earlier they were not using. And then you have Chinese, then you have Japanese also, and then you have Thai and many other languages which are not using white spaces. And in fact, it becomes a challenge because how will you then differentiate where a word starts and where a word stops? And then, in fact, it has its roots in the historical use of the languages also, because earlier, the Chinese people used to write it vertically. So when you write vertically and when you are using images as they are using, so each image is like a character set in itself. It indicates something, it conveys something. So as soon as, because vertically means when you go from first line to second line, naturally there is a demarcation, there is a differentiation. Okay, that this word stops here and this is the second word. But English is comparatively very easy language, and fortunately for most of the Indian languages, Hindi, Punjabi, Gujarati, Marathi, you have that, including Sanskrit, you have that concept of space. Okay, then in fact, tokenization is what I just discussed. You basically need to find the word boundaries so that you can tokenize it, so that you can make the text ready for further processing. In fact, tokenization is a generic term. And I have seen many a times people saying that tokenization means finding the word boundaries from a given sentence, which, okay, from a perspective of a general person, it is okay, but from a typical NLP perspective, this statement is not correct. Because tokenization, even though it uses the word token, this word token does not necessarily mean that it has to be a word only. Let me give you an example. So if you have one document consisting of 10 paragraphs, and if you are able to identify the boundaries of these 10 paragraphs, that okay, first paragraph stops here, second paragraph starts, second paragraph stops here, third paragraph starts. So if you are able to identify those 10 paragraphs, then these 10 paragraphs are nothing but 10 tokens. So basically you have tokenized your document, and the unit that you have used is a paragraph. And then in the further level, you may fine tune from a paragraph. You may have exclamation mark, you may have question mark, you may have full stop, and then you can separate these sentences. So in that case, your tokenization will identify the tokens where each token will be a sentence. And then from a sentence, you may have words. For example, when I say pre-processing in NLP, which is the title of this slide, then again, see here you need to take care of that hyphenated word. Will you treat pre-processing as one word, or will you treat them as two separate words? Because otherwise, what will happen is pre then might be removed as part of stop word removal, or its frequency will be less. So, and in fact, it will also change the semantics because then your bag of words, so bag of words means you have all the words put together and the order is not important. So then it will just have one word processing, which will not indicate that, okay, some pre-processing was also done. So pre-processing, let us say, is one word, then you have space. So in is the second word, then NLP is the third word. So these are tokens. So token can be paragraph, token can be sentence, token can be a word. That is the point that I am trying to emphasize. Okay, then you have the concept of stemming. Stemming means, for example, you have happy, happily, happy, happiness. So if I remove this ly, basically it is called a suffix stripping algorithm. And if I remove this ness, ness, if I remove es, if I remove s, so from boy, so from boys I will get boy, from girls I will get girl, ugliness I will get ugly, happily I will get happy. So basically this is called stemming. But then you have some issues with stemming, like if you have something called similar and similarly. So you will basically your suffix stripping algorithm will remove ly. So from similarly you will get similar. That is fine. But what about ugly? You will just get ug, which is not having any meaning. And what about poly? Poly, poly, which could be name of a girl also. It could be poly means many. For example, polynomial. And what about lily? Lily is name of a flower, could be name of a girl. So we will be just left with po from poly and lee with from lily, which is not making any relevance. So that is the issue with the stemming and suffix stripping algorithms. And see, the problem with stemming is also the fact that the word that you are getting after the suffix removal may not necessarily be the word that we are expecting. For example, if we have vowels, WOL, I don't know whether I will be able to write it properly or not. But if we have something like WOLVES, and if my algorithm is removing S, for example, to convert plurals to their singular form, so it will just leave wall, which is not having any dictionary meaning. And if my algorithm is removing ES, so E will also be removed. So what will be left is just WLV, which is not having any meaning. So that is the problem with the stemming. And therefore, we have another concept called lemmatization, which basically gives me the lemma. And the other problem is that so in case of lemmatization for valve, it will give me valve, the exact word. And the other problem is from runs and running, ing is removed, so I will get run. But what about best? Best. What about better? So stemming will not help. So these are the cases where lemmatization will help, because from best, lemmatization will give me good. From better, lemmatization will give me good. From good, lemmatization will give me good. So for good, better, best, lemmatization will give me good. But for stemming, it will remain the same. So lemmatization is more complicated, but then it is more advantageous also. And whether to go for stemming or lemmatization or both, it again depends on the task that you have taken. And see, typically, task is a word, because I have been using these words quite times. Task is a word which is used in NLP and perhaps in many other areas of artificial and computer science and engineering also. Task means you have a specific domain and you have a specific approach. So, for example, if I say I am using principal component analysis, I am using SVM, so sort of approaches. And then I have a domain. I am using the data from the medical domain, or data, I am using data from Twitter. I am using data for movie reviews, for example, for sentiment analysis could be the case. So basically, combination of the domain and the approach is called task in NLP. And see, all of these definitions are not that standard. Sorry. So this is the general convention. And then we have the concept of normalization. See, on one side, you can say that all of these activities that I explained here are a part of normalization of text only. That is a valid statement. But on the other side, you might find many that normalization is something like if you go to Twitter, you may find something like this. So what is this? This is good. But if someone has to, express that it is too good, then perhaps the person will write like this, or the person may write something like this also, God or GOOOOD, good. So as part of normalization, you can take care of these type of words, and then you can convert it to actual word. Now, how to treat them is going to be a real challenge. So it is another challenging area, because this is just one example, good, where you can normalize them, but then you have to take care of all the possible words. See, one possible approach which is used for this type of task is to replace multiple occurrences with a single occurrence. For example, you will rarely find any word, at least in the English language. See, again, it depends and differs from language to language. But you will rarely find any word in English language where you have 4 times O or 4 times, for that matter, any character. So you can use regular expressions. So a particular threshold value n equal to, let us say, 4. And if the occurrence is more, then you can keep on reducing it by 1. Keep on reducing, because you will have to do it continuously in a loop, because this is an example of 4, but you may have 8 also, you may have 16 also, so you will have to keep on doing it repeatedly. So this is all about pre-processing in NLP. Moving further, these are a few broad areas of NLP, and why I say broad areas, because any research work, most of the time, any work that you will be doing, or that you will be reading, or you will be going through, you will be observing, will be directly or indirectly related with one of these areas. So the first part is syntax, and in fact, I will be listing 4 of them, and these 4 are also called the characteristics of a word. Word, which is a basic unit for natural language processing. It is the smallest unit. Obviously, then you can think of characters and letters also, but generally word is the one which is processed because it conveys some meaning. So syntax means the grammatical rules, how the sentences are formed. And this also leads us back to the same concept of a rationalist approach and empiricist approach, because the rationalist approach used to say that there is some sort of syntax which is innate in the brain of a child, whereas the obviously it did not say that 100% syntax is there, but when a child speaks, it has some order of words which may not be correct, but then it has some structure. At least uh, it conveys something, and someone who is listening to it can understand that, okay, this is what the child wants. So that is about syntax. Then you have semantics. So syntax basically deals with the structure of the sentence, for example, and semantics deals with the meaning, the sense it conveys. Then you have pragmatics. So pragmatics basically deals with the context. I am giving a layman definition. Pragmatics basically gives the context. And I can give you one example of pragmatics, like just imagine a person who is, I have read this in one of the books, who is a pedestrian standing on roadside and shouting, taxi, taxi, and then the taxi driver stops there. But this is possible in the real world, because they have that concept of pragmatics. They know what is the context. So the taxi driver knows that basically the pedestrian is not shouting on the taxi when it says taxi, taxi. It basically wants the taxi driver to come there and stop there and pick that person. And from perspective of NLP, it becomes a challenge, because unless the context is there, and it is very difficult, to make the machines understand the context. So just imagine a pedestrian shouting taxi, taxi, and the taxi driver in turn shouting, okay, you pedestrian, pedestrian. It's not going to work. And then it becomes a problem with the natural language processing. So pragmatics basically deals with the context, how a word is used, which is sense it conveys. And then you have discourse. Discourse deals with the relationship of the sentences. For example, in a paragraph, And this reminds me of one very famous example. There was a traveler who was just leaving from his hotel, and when that traveler came to the ground floor at the reception, let us say, uh, uh, it just came to his mind that he has forgotten his shoes in his room itself. And he was in hurry because he had to, sort of catch a flight, for example. So he was in hurry. So he had to immediately sign out from the hotel and leave it so that he's not missing the flight. So he called the room boy or waiter and said, "Will you go to my room and see if my shoes are there?" And the waiter goes to that room and then immediately comes back and says, "Yes, they are there." So this is where discourse comes into picture. See, the intention of the traveler was not literally to see whether the shoes are there or not. He knew that the shoes are there. But his intention was to, go to that room and immediately bring those shoes to me. I am in hurry. But what he said was, and this is what we generally do when we use English language. So okay, let me first complete this example, then I will switch to the second example. But what the waiter did was like, yes, you asked me to see those shoes, and yes, I went there and I saw that your shoes are there. So this is where discourse and discourse analysis comes into picture. For human beings, it is fine. We can understand that actually what he intended was to actually bring those shoes, not literally see those shoes. But when it comes to computers, it becomes a problem. We need to make computers understand, and that is where that empiricist approach comes into picture. That is where this non-symbolic approach and statistical approach and deep learning approaches come into picture. That is where the Turing experiment comes into picture, and that is where John Searle's experiment comes into picture. That we are not designing artificial intelligent machines which are just simulating the human behavior. We intend to design the machines which are understanding, not just simulating. And yes, it reminds me of one more example. So generally we say something like this: okay, if you want to do this, go and see XYZ person in his room, in his or her room. So obviously, it does not literally mean that you have to, open that person's room and okay, I have seen you. Okay, then close it and come back. So this is where discourse comes into picture. That is the point. And then we have speech. See, when I was talking about the languages, I talked about isolate languages, extinct languages, endangered languages, dead languages, and so on and so forth, and the sign language as well. We also have to remember that speech is also natural language. In fact, there are many languages for which you do not have the written part. It is just spoken. And in fact, those are the languages which are on the verge of extinction because you do not have the written part. So as soon as their speakers are dead, these languages are extinct. But when we say natural language processing, it may be text or it may be speech also. So having given you these broad areas, and this list may not be exhaustive, I can understand. See, you can go through n number of papers, research papers. You can go through n number of books in this area. You will each time you will find a different broad area listed, and in times to come could be many more also. But these are the broad ones, just to give you a rough idea. So whatever you are doing, or whatever you are reading, try to analyze it from this perspective. It will, and ideally it should fit in one of these areas. For example, when you talk about WordNet, it deals with semantics and it deals with the pragmatics also, because you need to find the context. And if you are dealing with, for example, what is it, emotion detection or sentiment analysis, basically you are trying to get the meaning of the words. So basically you are dealing with semantics and so on. More broadly speaking, I will say that it will be dealing with either images or speech or text. So in a way, you can say that in these three words, to a great extent, NLP is covered. So either it will be image or it will be speech or it will be text. Okay, text you can understand, speech you can understand. I will give you one example of image. For example, if some text is written on a paper and you are designing an algorithm that can actually read it, that can identify the characters. So character identification, optical character recognition, and then handwriting recognition, and then you have many old scriptures and books which are written in this script, which used to be prevalent in that point of time, and you have to make computer understand that okay, this is what is written. And one typical example will be like, and this is something that we are facing in our day-to-day life also. You have a document and you are scanning it through the scanner. So what you get is image, and then you sorry, and then you need to convert it to text format. Though it works well with many of the applications, and we have many online tools also, which provide you conversion from PDF to text as well as from image to text. But just imagine a document which is colored, and then the tables are not aligned properly, and then if you scan it, you will not get the exact text version of that document. So all of these areas are covered under NLP. That is the point that I want to touch on. Okay, and then you will find that whatever work is done as far as NLP is concerned, it will be dealing with one of these two. Either it will be natural language generation or it will be natural language understanding. Most of the work which is being done in the area of NLP, so you can say that these two are like two branches of NLP. Most of the work which is done is in area of natural language understanding, NLU. And naturally, natural language generation is more challenging because you have to make a machine generate the language the way we do, which is a bit more challenging. And in a way, it also takes you from the simulation to understanding part. But it is still a challenge because it is not that easy to make machine generate the language. And then it also includes one application where some data is there in data marts used to exist in the good olden days, and data warehouses and databases. And then you are designing an algorithm which is fetching the important data and the patterns from that, and it is providing it in the form of a text instead of going through all of those tables and joins and so on. So that is also an application of natural language generation. Well, very important and important in the sense enjoyable rather application of natural language generation is creation of text. So we have full-fledged and very mature applications which are available, which can produce fake news. So now this may sound a bit awkward also and contradictory also, because on one side researchers are working to summarize the text and to understand the text, but on the other side, see, every coin has two sides. Another group of researchers which is sort of negative working, but it is possible now. They are able to create fake news. So if you will go through that news item, you will not come to know immediately that, okay, is it fake or not? And that is how rumors also spread. And not only that they are able to create fake news, they are able to create fake stories. Or perhaps we should not say that it's a fake story, but fictions, for example, from linguistic perspective. And in fact, when I use this word linguistic, let me tell you, see, there is a flow. So earlier, what used to happen, people were working on languages. And then people started to use computers for working on those languages. So that was the time when computational linguistics came into picture. So first you had linguistics, then you had a separate branch called computers and computer departments, which basically started in the mathematics and statistics departments in all of the universities at that point of time. And then came the concept of computational linguistics, which basically was using the rationalist approach or the symbolic approach. And basically it had rules, and those rules were processing the languages. And so it was computational linguistics. And then obviously you will have some overlap among these areas, and then came the concept of natural language processing, which is like an extension of computational linguistics. And again, it is a debatable, because you will find some people who will say that computational linguistics of CL is a branch of NLP, or NLP is a branch of computational linguistics. But I personally believe that first you had linguistics, then you had computational linguistics, and then you had this full-fledged NLP. So I will say that computational linguistics is a branch of NLP, which basically takes care of the symbolic part and rule-based programming for processing a particular language. Okay, coming back to our original point of discussion. So you have applications which are also able to generate poetry, and that poetry might not be, that well, but yes, they are able to do it. And I have included a few slides. So this is an example of auto-generated poetry, and I have included the source also. You can go there. And basically, this person has used RNN, or a recurrent neural network, to generate this poem. In their little room with the door ajar and the candle hanging on the wall ajar, I have came across the word rise with a face as grave and flat as you please. So this is auto-generated poetry, artificially generated poetry. Now, who will tell me that this is not real? See, because otherwise also poetry is created like that only. So if you go through it, anyone will get the impression that it is actually written. And see, processing of poetry is a real challenge. And I have guided a few candidates who have been awarded PhD. And I have worked in the area of Punjabi poetry. Punjabi happens to be my mother tongue. And so we worked in the area of Punjabi poetry. And then after living in Chandigarh for 10 years, I shifted to Gujarat, where I stayed for approximately 30 years. So Gujarati naturally was. So again, I will have to go with the racist approach, because Gujarati is something which was not my mother tongue, but I came to know and I came to learn Gujarati through my experiences, through my interaction with others. And I guided many candidates for classification and testing work as far as Gujarati language was concerned. And then there are a few candidates who have completed machine translation from Sanskrit to Gujarati and so on. We use constituency mapper and bilingual dictionary and so on. Okay, so coming back to the auto-generated poetry, this is one example. And this is another example. And I had included this example intentionally just to, point out that because for a person like me who is conversant with so many languages, English and Hindi will not be just sufficient. So this is in Russian. This is in Russian. I have personally worked on Burmese, Punjabi, Hindi, Gujarati, Sanskrit, Telugu, Marathi. Now that I am in Pune, and Saraiki is like sort of Punjabi only, and it is also called Multani language. It is sort of dialect of Punjabi. Now that is a bit controversial area, because some believe that it is a full-fledged language in itself, and then some others believe that no, it is a branch or it is a dialect of Punjabi. But we will not go in that political part. For us, the point is that these are two different languages. And I mean, just to see how many languages are we using daily. When I have to pray, I am using Sanskrit. While talking to my parents, I am using Punjabi. And you should not be surprised, the version of Punjabi that is used by my mother is different, and the version of Punjabi that is used by my father is different, because both of them hail from two different parts of Punjab. And if you see, the Punjabi spoken in the Amritsar part is different, and the Punjabi spoken in the Delhi part is different. And then you have this concept of Hindustani language, which is basically a sort of combination, sort of point where these two languages mingle, Hindi and Urdu. And on the sidelines, let me also share that it happens to be among the top 5 languages spoken worldwide. First, if I am able to recall it exactly, it's Mandarin, and then obviously its variants. And first is Mandarin, then you have Spanish, then you have English, and yes, then you have Hindustani, which is basically a combination of Hindi and Urdu. And then obviously, if you treat Hindi as separate language, then you have Hindi separately. Okay, so this was one example of auto-generated poetry in Russian, and guess what? Yes, I thought that I should include something in Hindi also, so that you are able to understand it. So इश्क करने का शौक नहीं है, बस इतना समझ लो, देखिए किस कदर रोया है, कोई कहता है प्यार सजा बन जाता है. Now, who will agree that this is not written by an actual poet? This is actually auto-generated poetry. And this is another example. इश्क करने का हक है तुम्हें, पर नाराजगी में कहीं ये मत भूल जाना कि देखिए किस कदर करोगे. Now see, भूल जाना कि देखिए किस कदर करोगे, it is not conveying any sense, because it is artificially generated. So at least this particular line, I can understand that it is not written by a human being, it is computer generated. But if you have the first example, इश्क करने का शौक नहीं है, the one with this sentence, no one will agree that this is not written by a human being. So these are the examples of auto-generated Hindi poetry. Coming back to our original discussion, I talked about the NLP broad areas, syntax, semantics, and discourse, pragmatics, and speech. And I also told you that these are also the characteristics of a word, which is the smallest unit when it comes to natural language processing. And this list is neither exhaustive nor a standard one, because some researchers believe that okay, pragmatics and discourse should be included separately. Others believe that no, they should be combined. Others believe that morphological analysis should be included. I believe that morphological analysis could be treated as part of syntax only, and then you have part of speech tagging, wherein you identify for a given sentence whether it is adverb, clause, or whether it is noun, adjective, pronoun, and so on. So I will include that part as part of syntax itself. So there are different schools of thoughts, but this is the broad area. That is the point. Moving further, we have these NLP areas. So these are a bit more specific compared to the previous slide. So we have word segmentation. So, okay. See, technically speaking, I will put it this way. You have tokenization, which I explained in one of the previous slides, where you have paragraph as a token, you have a sentence as a token, and so on. So when you have a word as a token, when you are splitting, when you are identifying, when you are detecting, when you are separating, when you are demarcating, when you are differentiating a word from a sentence, I will say that it is word segmentation because you are finding words separately. So in a way, you can say that word segmentation is a type of tokenization. And then similarly, you can have paragraph segmentation, line segmentation, and so on. See, I don't know whether you knew about this concept or not, but next time when you are listening to these terms, at least you should be conscious and aware enough to understand that these are different terms and they indicate different meanings. If it is tokenization, if it is word segmentation, if it is paragraph segmentation, and so on. Okay, so this is an example from German language, and this is a valid real world word. This is a valid word. It means insurance companies which provide legal protection. This is a valid German word. So for languages like German and as I said earlier also, in any case, German does make use of white space characters to differentiate two words, but then you have these type of words also. These are called compound words in German. And this is another example, which is even longer actually, which means life insurance company employee. And just imagine if these two words are combined together, you will have the one sentence with approximately 100 odd characters. So it becomes a real challenge in the case of word segmentation. And see, most of the languages, they are like related. So for example, in the Dravidian language family, if you have a look at the word appa for father, if you see Telugu, Kannada, Tamil, and Malayalam, appa or appa, you will almost find a similar root of the word. And perhaps because they have all been derived from the same parent language. Could be Sanskrit. Now it is debatable, but for the time being, we assume that it is Sanskrit. Similarly, for the North Indian languages, also earlier, 5,000 years back or so, approximately, and again, it is a bit controversial because different researchers believe differently. But then you had Sanskrit language, which again had two types. You had like Vedic Sanskrit, and then you had Laukic Sanskrit, and from Laukic Sanskrit came the concept of Pali, and then came the concept of Prakrit. Now again, it is debatable whether the Prakrit came first or the Pali came first. But it goes something like this: you had Sanskrit, and then you had Pali, and then you had Prakrit, and then you had the concept of upbranch of those languages. It means basically the distorted versions of those languages. So you have Shorseni upbranch, particularly which is spoken in the, Shorseni was basically a king in the Pandavas period. So he was related to the family of Lord Krishna, and then he was one of the Yadavs. And then this region of Kurukshetra, Haryana, in fact, entire region of Haryana, Punjab, Delhi, and to some extent towards Himachal Pradesh also. So the language, even which is spoken as on date, if you are speaking Himachali, if you are speaking Pahadi, if you are speaking Haryanvi, if you are speaking Punjabi, if you are speaking any version or dialect of Punjabi, so all of these languages are basically derived from this upbranch. And then it had another upbrush, which was towards Gujarat. So Gujarati came into picture, and so on. So this is how the languages have evolved. I was just trying to provide you with a brief overview how languages have evolved. Otherwise, if you have to talk about, I mean, if you ask me to talk about Sanskrit, Pali, Prakrit, I can dedicate full day, and still I will have something to say, but the day will fall short. And just imagine a person like me who has been working in the area of NLP always imagines Lord Rama, who was born in Ayodhya, and Ravana, who was in Lanka. And if we believe that it is the modern day Sri Lanka, now just imagine, see, it is typically said that every few kilometers your language changes. And I said that the version of Punjabi, even which is spoken by my mother, is different, my father is different, my wife is still different. And my father's brother, the Punjabi which is spoken in his family, now they are real brothers, but the version of Punjabi is still different. So if you go to Amritsar, it is different. Hoshiarpur, it is different. You go to Pathankot, it is different. You go to Delhi, it is different. And just imagine a person from Ayodhya and a person from Lanka, how they used to communicate. But this again is a bit controversial, but I believe that when Vibhishna came to Rama's side, perhaps he was, helping him to translate what Ravana was speaking, and then again translation from what Rama was speaking back to Ravana. This is what I assume. And this reminds me of another concept. See, as on date, translation services from the perspective of natural language processing, they are very costly services. I mean, there are professionals who will charge you like up to like rupees 2 and 3 per word for translation. So I believe that the task was done for free by Vibhishna. And Hanumana, who was in the, because Sugriv was in the Kishkinda region. So Kishkinda is like modern day Karnataka. So if he was in that region, he must be speaking Tamil at that point of time, because Tamil is the older language and it is derived from Sanskrit. So if he was speaking Tamil and Hanumana was his assistant, then he was also speaking Tamil. Then how were they communicating? And one possible answer to this question is perhaps Sanskrit. Because Sanskrit used to exist at that point of time, and it was the older language, it was called the Dev Bhasha. And then perhaps, and it is also that all of these people, Ramana, Rama, Hanumana, and so on, they were very learned. So, see, if I can speak Marathi, if I can speak Hindi, if I can speak Multani, if I can speak Punjabi, Hindi, English, so many languages, then we can assume that they were also able to speak these many languages, and that is how communication used to take place. So that was just on the sidelines, just to give you an idea of the roots of natural language processing and the evolution of the languages. Okay, and even as on date also, see, there is always an evolution of the languages. I mean, the languages are never stagnant. At least I will be the last person on this earth to believe this statement that the languages are stagnant. So recently we had one movie. I am not in habit of watching much movies, so I am not able to recall the name of that movie. You might be knowing it better, but I think Kajal was there and helicopter something was there. So based on that concept, now we have a new term. It is called helicopter parenting. So helicopter parenting means the parents are, always keeping watch on their children. So a new term has come up, helicopter parenting. And similarly, there are many more terms like for addiction of internet, for addiction of Facebook, and so on and so forth. Even the word Facebook, before 70, 80 years, I don't think that, forget 70, 80, even 50, 60 years back also this word was not there. So the language always keeps on evolving, and the mix of the language is a challenge for NLP. So that is the point that I want to emphasize. See, it is good that the languages are evolving, fine. I mean, let us stay neutral whether it is good or bad. But from the perspective of natural language processing, for a scientist who is working in the area of NLP, then it becomes a challenge. For example, you have ये जिंदगी न मिलेगी दोबारा. I think that is the name of a movie, and you have one very famous song, No Desvis La Mirada, Ke Date Sarka Devi, Tum Yun Is My Pharaoh, and so on and so forth, which is basically written by Javed Akhtar ji and Senorita. That song is called Senorita, and it pictures Hrithik Roshan and Farhan Akhtar and so on. Bobby Deol, I think. I don't remember. But basically, the language which is used in that particular song is a combination of two languages. It uses Spanish, it uses Hindi. So when I say, Desvis la mirada que da academy, basically it means don't look here and there. Look at me, I am here. And so basically, again, it is a combination of two languages. So from NLP perspective, it becomes a challenge because if you have designed an algorithm, assuming that this entire text is from one language, then as soon as you get text from the other language, then the words will be treated differently, and you may get a different output. For example, we were just discussing the case of German also. And there is another song from I don't remember which movie, but Do Lafzon Ki Hai. So basically, in that song also there is some other language which is spoken by the singer, and then you have this very famous song. Uh, uh, I don't remember who had written that song, but a very famous song, Chiya Chiya. Chal Ishq Ki Chhaan Chal Chiya. So basically, if you treat that song from perspective of NLP, it is a challenge because it is not completely pure Hindi. So Chiya Chiya basically means in shade, in shade of love. That means chaya. In Hindi we call it chaya. प्यार की छाया में चलो ताकि धूप ना लगे, for example. So from NLP perspective, it is a challenge because it has a combination of so many languages. There are words like Gulposh, Firdaus, Jannat. So all of these words are not originally used in Hindi language. So they are like borrowed words. In NLP, we call them borrowed words or loan words. So it becomes a challenge. And so on and so forth. So you have so many of those cases which from NLP perspective become a challenge. Okay, moving further, we have the concept of scanning. I have already discussed it, so I will not be talking about it again. Lemmatization, I have already discussed it, so I will not talk about it again. See, you might be wondering why there is a repetition of these 2 points. Because as I said that I have been delivering talks on the area of NLP every now and then. So sometimes this happens. Some slides from some other presentation lead to this redundancy. Then you have something called POST, and believe me, this POST is not power on self-test. This is part of speech tagging post, wherein, as I said earlier, also you have to identify which word is adjective, noun, pronoun, and so on. And then you have morphological analysis. So morphological analysis basically deals with the, and that is why I said that it is part of structure. So morphological analysis basically deals with the formation of words and their structure also. And we have the concept of morphemes then. Morphemes means like E or ES or just the S. So if I add morpheme S to let us say boy, then it becomes boys. So boy is a morpheme, S is a morpheme, and I am using these 2 morphemes together and it gives me another word. So in morphological analysis, you have the concept of conjugation and declension. So conjugation means, now this may sound a bit complicated, but conjugation means you have basically the application of inflectional rules for verbs. And for nouns, for example, you have the concept of declension. For example, for verb, I can say from break, tootna, break. From break, you have breaks. And then you have the concept of word formation. So word formation could be like compounding the words, like dog, you have one word, and catcher, you have another word, and then you have another word, dog catcher, and so on. So this is all about the concept of morphological analysis. And moving further, you have concept of terminology extraction. So given a document, which terms it is using, the important ones, the terminology that it is using. So this algorithm will basically extract those terms. Then you have the concept of optical character recognition, which I already discussed. You have a document and you have to identify the characters which are written on that document. See, OCR is quite an established area now. But this reminds me of one concept of artificial intelligence, and I don't know whether you know about it or not. In world of AI, it is said that, and this is applicable to NLP also, something which has been done by AI is no longer AI. So, for example, speech processing is concerned, or text to speech is concerned, for example, it is already done. So now it is no longer a part of AI. Now you will have to think of some other application. So that is the beauty of AI. Okay, then we have the concept of lexical semantics. Semantics means meaning. Lexical semantics means the meanings of words. So word level meaning analysis is done as part of lexical semantics. For example, if I say river, sorry, if I say bank, so then this bank could be the river bank, or it could be the financial institution. Or if I say book, so it could be a verb also, for example, book a ticket, or it could be a noun also, the books that we read. So that all goes with the lexical semantics, and that is also where word sense disambiguation, WSD, comes into picture. Another area of NLP, another area, or even you can say that it is one application also, is machine translation system, where you are translating from one language to the other language. And then you have various approaches. For example, you have rule-based approach, you have a statistics-based approach, and so on and so forth. And translate.google.com, for example, with all due acknowledgement to Google, is a service which is provided by Google, and it provides this translation service. And many Indian languages are included. And I don't know, I have not counted it, but I think India will be the only country in the world which has these many languages included as part of translate.google.com. But still, there are many issues with Google's translation. And I have one slide which has been dedicated for providing you with a glimpse of what are the problems with Google Translate. Then we have the concept of named entity recognition. So, for example, if I say I met Dr. Unish in, let us say, Chandigarh. So, Chandigarh is a named entity, Unish is name of a person. So, an algorithm which identifies all of these is called named entity recognition, and it is really helpful for many forensic-based applications also. Then you have the concept of sentiment analysis, which is having various variants like sentiment analysis, emotion detection, emotion recognition, polarity identification. And basically what we are doing is, given a text, we are identifying the sentiment. Either it could be positive, or it could be negative, or it could be neutral. For example, if so initially, the standard application was like with the movie reviews. And for that matter, why just movie reviews? It could be any product. It could be review of a restaurant. Now, see, the word restaurant itself is a French word. In English, we say restaurant. And I have written also, I have seen the written format also, restaurant. Actually, it is a French word, and it should be correctly pronounced as restaurant. So that is where this concept of loan words and words from other languages comes into picture. For example, the word Almira, and so on. And even the word khoon, blood, which we use in Hindi, is not actually the correct Hindi word. The correct Hindi word is rakt. But this may sound a bit awkward. So if there is some injury and if you say mera rakt nikal raha hai, people will literally laugh, and generally we say khoon nikal raha hai. So see, that is why I say that languages keep on evolving, and once those words are in the language, and then they become like the daily routine word. Okay, so we were talking about sentiment analysis. So you have positive reviews about a restaurant, or could be a mobile phone, could be any product for that matter. And it could be positive review. I mean, if someone says it is good, or if someone says it is not good, then it is negative review, or someone will stay neutral that it is okay. And the challenge here is that you cannot just identify the words. See, one way is to identify the words for these sentiments. For example, if someone says it is good, then good indicates positive polarity. But if someone says it is not good, and if you are using unigram approach, okay, so you need to understand what is unigram. So we have the concept of engrams. Engrams means how many words you are treating together at a time. So, for example, if I say optical character recognition, this is 3 gram because there are 3 words. If I say character recognition, it is bigram because there are 2 words. So, if I am just taking one word at a time without their order, as we do in the case of bag of words, which is also called set of words, BOW or SOW. So you will not know which word was before it, which word was after it. And in fact, word to word when other algorithms have uh, extended this area to an extent that it has now become quite mature. It can predict which are the words in the window before it and after it. And so that is the concept of word to word. Coming back to our original discussion, sentiment analysis. So if it says it is good, good is giving you positive polarity. But if it is saying it is not good, and if you are treating it as unigrams, then based on word good, you will come to know that it is positive. But actually, if you take bigram not good, then you will have to understand that it is negative polarity. So that becomes a challenge. So that is done as part of sentiment analysis. And this reminds me of one of my research works where we did sentiment analysis using the concept of Navaras of the Indian tradition. So we have Shingar Ras, Hasya Ras, Karuna Ras, Raudra Ras, Vibhats Ras, and so on. So basically, we classify the poetry based on the concept of Navaras, which is basically an application of sentiment analysis. Then you have topic segmentation. So given a document, if it consists of multiple topics, then this algorithm will tell you that, okay, this is topic 1, this is topic 2. And if it is the same topic, then it will sort of give you the title. And given these tasks together, I believe that, for academicians and even for many people in industry also and for students also, writing a research paper is very important. So what you can do is you can just deploy 3 algorithms. Number 1, topic segmentation. Number 2, terminology extraction. And one I will just discuss. It is called summarization. So basically, you write one research paper, and then your terminology extraction algorithm will give you the keywords, and your topic segmentation algorithm will give you the title of that research paper, and your summarization algorithm will give you the abstract of that research paper, and your entire work is done. And this is going to be the future. I mean, people have already started working in this direction, and I had already shown you a few slides where auto-generated poetry was there, and I talked about auto-generated news articles also. So word sense disambiguation, we just discussed, you need to find the correct sense of the word. And the summarization, I just talked about that it will provide you with the abstract of what is written. And this is actually all of these definitions that I am giving you are just for the basic understanding. It is quite at the level. And summarization, again, then you have 2 types, abstractive summarization and extractive summarization. In case of abstractive summarization for a given text, the sense of the text is abstracted, and the same words may be used, but the phrases and same sentences are not used. So that is abstractive summarization. And in case of extractive summarization, the algorithm typically extracts the phrases and the sentences and puts it in the created abstract. So that is extractive summarization. And now I will discuss a little bit of parlance of NLP. It is almost 12 o'clock. The time that is given to me is from 10 to 1. So I think I will be able to complete it by 1. Here we have the concept of verb. For example, in English, we say, let us take one example. I ate an apple. So I is subject, and ate is verb, and apple is object. So the word order is SV. But if I have to say this in Hindi, many seb khaya. So many seb is object, khana is verb. So we. And you will be, I don't know, happy or surprised to know that almost 1/3 of the languages of this world. By the way, how many languages are there in this world? Approximately 8,000. Well, that is also something that you need to know on the sidelines. So 1/3 of those languages use SOV order. And this is not a coincidence, because I said that Indo-European language family happens to be the largest language family. And India happens to be one of those 7 regions which are very diversified when it comes to different languages. And so in Hindi we have SOV, and in Punjabi मैं सेब खाता, और in Marathi me सफरजन खाला, or in Gujarati मैं सफरजन खादू. So basically it goes for most of the Indian languages, it goes with SOV. And one third, no, I said approximately half of the languages of world use this order, and approximately one third of the languages use SVO order, including English. So English also uses SVO. And there are 3 terms now: object and verb. So basically there are 3 factorial, that means 6 combinations. So we have SVO, we have SOV, then we have V, O, S, and V, S, O, and then we have O, S, V, and we have O, V, S. This is the most common used in world, and this is sort of at the second position. And for the remaining languages of world, all of these are used. So it is not so that we do not have any language which is not using OVS or OSV. We have at least a few languages which are using one of these word orders. But SOV and SVO happen to be the most important ones. Okay. So that was all about word order. Word order is important because if you have to go for machine translation, for example, or if you have to go for the analysis of the semantics of the words, if you know that, okay, at this position in a sentence, this is the word, and even for part of speech taking also, if you know that, okay, this is Hindi, so first word has to be subject, second has to be object, and verb may come only at the last. So this helps for those algorithms, and even for machine translation also. See, for example, if you have to translate and you're trying to put it very simply, and you will appreciate, this is a very comprehensive example. If you have to translate a sentence from English to Hindi, I ate an apple. So identify that I is subject because this is in English, and ate is a verb. Ate is a verb, and object is apple. And you know that apple is called same, and verb is khaya, khaya, khana, and so on. It's morphological variations. So see, this is the point where morphological variations come into picture. And subject means I matlab in Hindi mein. So it first will get translated in some form like मैं खाया से. But we know that in Hindi the word order is SOV. So वो बन गया मैं सेब खाया. Now it gives मैं सेब खाया, and now you can further fine tune it to give you मैंने सेब खाया. And, then we have that concept of for example, in Sanskrit, we call it first vibhakti, second, third, fourth, and so on. For example, in Sanskrit, we typically have the concept of jana, 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 and so on. Or ni, vah, mah, si, tha, tha, ti, tha, ti, vah, mah, si, thi, 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 thi. So basically, all of this concept can be used for translation. For example, if pat is the root, dhatu, and me, vah, mah, si, tha, tha, ti, tha, ti. So prathama vibhakti ek vachan. So patha, me, मैं पढ़ता हूँ. So this is just an example. I will not go in that detail, otherwise it will become difficult for you to understand. But basically, the point is that word orders do help in natural language processing. That is the point. So translation means sorry. So translation means you are translating from one language to the other. For example, मैंने सेब खाया, मैं सेब खाता. जैसे जिस तरह से पंजाबी कहनी है. So that is translation. The sense remains the same. That is important for translation, and at least it has to remain same. That is the purpose of translation. Then we have transliteration. So if I say "आप कैसे हैं," and if I write something like this, "आप," double A P. So this is transliteration because I am using Roman script. I am using Roman script to write Hindi. So this is transliteration, and this is generally we do when we use Twitter or when we use WhatsApp and when we use SMS. So it is transliteration. And transliteration again becomes a challenge for people like us who are working in the area of NLP, because then you need to first identify whether it is Hindi or whether it is English or whether it is any other language, because you have used the script of English, which is Roman, and some say it is Latin also. But what you have written is not English, so you will not find any dictionary meaning of the term in dictionary. So lexicographic problem. Okay. Then you have language, speech, dialect, and script. So something that can be used for communication is language, as I discussed in one of the second slides also. Speech is the spoken part of the language, the utterances, that is speech. Dialect is the variation, the variant of the speech. Generally, dialects exist with the spoken part only. And when it comes to the written part, most of the languages have the formal versions. For example, in Hindi, I may say, "Tu kaisa hai?" "Tum kaise ho?" Or in Marathi, we say, "Tumi kase aahet?" So, many times it is quite informal. But in Hindi, for example, in Hindi, when it comes to formal, we say, "Aap kaisi hain?" or "Aap kaise ho?" So the formal language and informal languages are generally different. And this is the problem with NLP, because for formal languages, you can have more systematic structure. But when it comes to the spoken language, it becomes a bit more difficult. For example, generally we inform say, "Hey, tu kaisa hai? Arey yaar, kya kar rahe ho?" But in written Hindi, rarely do we find this type of text. For example, in formal official writings of the government, and in the scientific literature, for example. So it is more formal. That is the point. And hence we have these two variations. Okay, the last part is script. So script is the sort of mechanism which is used to code that language, to put that symbols on paper. And typically it is said that for mathematics, symbols do not have multiple meanings. But when it comes to natural languages, symbols have multiple meanings. And just to make sure that I am able to maintain the level of this discussion, I have not discussed language as a mirror, language as a game, and the philosophy of language. But script is like for English, if I this A, sorry, if I write this A, so this is scripted in Roman, English scripted in Roman, English language scripted in Roman or italics. If I say, oh, this is Devanagari script. And similarly for Uda, Ada, Ida in Punjabi, we have Gurmukhi script. And then we have Shahmukhi script also, basically the version which is used in Pakistan. And in many parts of India also. So basically these are the scripts. And for example, this is Gujarati written in Gujarati script. Gujarati script is different. And there are many languages which use their own script, and then there are many other languages which use Devanagari script, which is itself derived from Brahmi script, and you can dedicate a full day in discussing about the scripts. But then there are many languages which have their own script, for example, Gujarati. And then you have Rajasthani, which uses Hindi script. Devanagari script. And Hindi itself uses Devanagari script. And Sanskrit itself uses Devanagari script. And so on. Awadhi uses Devanagari script. Braj Bhasha uses Devanagari script. And so on. So this is the difference between language, speech, dialect, and script. Okay, then you have something called character. So character is any mark. It could be hash mark. It could be any mark. Letter means A, B, C, K, K, G, Uda, Eda, Ida, and so on. So these are all letters. Alphabet means the collection of letters for a particular language. For example, in Punjabi we have 20. K, K, G. So that becomes alphabet. So from capital A to capital Z, or from small a to small z, there are 26 letters, and these 26 letters collectively create alphabet. So generally, I have seen that people use these two terms interchangeably and synonymously, but from the perspective of NLP, these are different. And for people like me who are, reviewing journals of ACM transactions and IEEE transactions and so on, we do take care to see, particularly in the area of NLP, because that is the area of language. So you have to make sure that the word that is used, is it language or is it script, or is it dialect? So if someone says Gujarati language, then we have to take care. Is it the Gujarati language or is it the Surti version or is it the Kutchi language? And similarly, if the person is talking about alphabet, is it alphabet or is it letter? So one has to be careful. And similarly, diacritic. Diacritic is typically what we call as matra in Hindi, and swar, for example. So could be E, bada E, chota E, and so on. So these are all diacritic marks and so on. And in fact, based on these matras in Hindi, in one of my research works with one of my research scholars, we are working for classification of Hindi poetry. And it is basically computational linguistic approach. Because in Hindi, we have the concept of chand, and which is equivalent to English meter. And then you have yagan, you have the concept of chand, and poetry, you have concept of like alankar, which are called figures of speech, yamak alankar and anupras alankar and rupak and so on. And then you have chand. Then you have types of like matrik chand, varnik chand, and mukt chand, and so on. Then you concept of ras. For example, I was talking about shringar ras and karuna ras, vibhats ras, hasya ras, and so on. And then you have the concept of yati, gati, tuk, and rhythm, for example. And then you have the concept of gun. And in gun, you have 8 types: yagan, magan, rag, and so on. So basically, that's why I said that it is a computational linguistic approach. So that approach was applied, and we were able to achieve 99.85% accuracy. Okay, moving further. Okay, this is quite interesting. So we have word, type, token, and term. And what is the difference? So in general, for a given sentence, a word is something that conveys some meaning. Type is a word which gives us the unique count. Token is the total number of words. Okay, let me take one example. So if I say, this is a sentence, this is another sentence. So a total number of tokens will be, total number of words, which will be called tokens, will be, this is a sentence. So 4, this is another sentence. So 4 again. So the total number of tokens will be, total number of words which will be called tokens will be 8. And type means we have this, we have is a sentence. This is a sentence. And in another case, we have this is, okay, we have another, so another sentence. So if you see the unique count is, this is another sentence. So 1, 2, 3, 4, 5. So type will be 5. And we have the concept of TTR. It is called type token ratio. Type token ratio in this case will be 5/8. And then you can multiply it with 100 also to give you the percentage. It shows the richness of the language that one uses. Naturally, if the number of unique words used is more, you will have more number of types. And just imagine a text which has no repetition of a word. So it will be rich linguistically. So that is the concept of, obviously it is not practically possible. So that is the concept of type token ratio. And obviously then you can consider the types by removal of stop words like is, a, another, this, and so on. And finally, we are left with the concept of term. See, there are a few words which are very statistically relevant or important from research perspective or from the perspective of the algorithm to achieve the functionality, which is the goal, which is the objective, which is the aim, which is the intention of the researcher. Those type of words are called terms. For example, if I say, this is a good pen. So is in any case is going to be moved as a stop word. This again is a stop word. Would could be important, and pen is important. So for further statistical processing from the perspective of natural language processing, NLP, the researcher will choose just two terms. So these words are now called terms, which are those two words which are used as terms. Number one, would. Number two, pen. So you can see that the words which are used by the researcher for research work, they are called terms. Okay, and then you have a phrase which is part of a sentence. For example, वहां जाकर. So now this is incomplete, like वहां जाकर क्या? वहां जाकर is a phrase. Sentence will be like वहां जाकर बैठ जाओ. So this is a complete sentence. And paragraph will be a collection of sentences. So we have a phrase. So first we have a word as a building block. Then we have a phrase. Then we have a sentence. Then we have a paragraph. Then we have a document, which is a collection of paragraphs. Then we have a corpus, which is a collection of documents. And the plural of corpus is corpora. So multiple corpuses, so to say, will give you corpora. And for NLP, we say that I need to have a text corpus or a speech corpus. So basically, it is that data on which I can apply machine learning algorithms for training and so on. So this was all about the areas and parlance. Now, these are a few sort of challenges and sort of my experiments also with NLP languages and research challenges also. And I will be stopping after discussing some 2-3 slides, and the session will be open for questions. First of all, I take the example of figures of speech. In Hindi, we call it alankar. For example, we say yamak alankar, anupras alankar, rupak, and then you have types of anupras alankars and so on. And in English, we have the concept of simile, metaphor, synecdoche, and euphemism, hyperbole, and so on and so forth. So the example is charan dharat chinta karat chitvacharan or subran ko khochat vi vyabhichari chor. See, from NLP perspective, it becomes a challenge because subran here has 3 different meanings, and you have to design NLP algorithm. Charan dharat chinta karat, that means a person is putting his or her foot and worried. Chitvacharu and looking here and there. And while the person is walking, that person is khojat firat, that person is searching for subran. And now the poet has given 3 types of that person. Number 1, kavi. Kavi means poet. So a kavi is looking for subran. Baran means like kha, ga, or rather instead of kha, ga, charan, dhara. So words, baran, word, जिसे हम बोलते हैं हिंदी में. सुवर्ण, अच्छे वर्ण. अब यही भाव समास हो गया. मतलब समास is also, when it comes to alankar, samas, ras, all of these are my areas. So suvaran means अच्छे शब्द. Poet is looking for good words. So that is meaning number 1. Vyabhichari is someone who is of adulterated nature, whose nature is not good. So subran. So if that is a male looking for a female, and if that is a female looking for a male, so looking for a partner, for example, that is second sense. And third sense, chor. Chor means thief. And in this sense, subran is suvarna. Suvarna means swarna. Swarna means gold. So a thief is looking for gold. So in the same sentence, we have multiple meanings. So from perspective of poet, it is quite enjoyable. A person like me who is writing poetry in Hindi, English, and many other languages, and published at international level also, for that person, this is quite interesting. When it comes to NLP scientist, it becomes a challenge because then you need to identify the correct sense. And see, you can identify this correct sense only if you have that context. If you know that, okay, Kavi has something to do with Subram. And Vyabhichari has something to do with Subran. Chor has something to do with Subran. Subran could be Swarn, Swarn could be Suvarn, and it could be gold. So that is where wordnet also comes into picture, where you have the concept of syntax. So for a given word, you get multiple synonyms, and you can check which one fits. The other example is Kali Gata ka Ghamand Gata. Now, Kali Gata is like black clouds. And in second part, Gata means reduced one. It got reduced. So Gata first usage is like clouds. And Gata in second sense is reduced. So Kali Gata ka Gaman Gata. So in one sense, you can say that the clouds were reduced. The sky became clear, for example. तीन बेर खाती थी वह तीन बेर खाती है. Here, bear in first sense is the fruit, and in second sense is the number of times. जैसे हम कहते हैं ना कि कितनी बार. So in second sense it is number of times. So तीन बेर खाती थी वो तीन बेर खाती है. So in one sense it is like she eats three fruits and that's it. And in second sense she eats three fruits three times. So this becomes a challenge. And in fact, this reminds me of one very famous another example. Sherlock Holmes or something, you can name any person, name does not matter. Okay, let me put it this way. The detective saw a man with binoculars. The detective saw a man with binoculars. Now the question is the detective using the binoculars to see a man? Or did the detective saw a man, that man was having the binoculars? So that becomes a question. And similarly, there is another very famous example. This reminds me of that example. A lost painting was found by a tree. So now tree cannot find a painting. Police person can find a painting. But the sense here is that the painting was lying beside a tree. It was lying near to a tree. So you can say that painting was found beside a painting was found by a tree. Okay, so this is from Gujarati. Tapeli, tapeli che. So tapeli means utensil, patila, that we call in Hindi. And tapeli che means tapi hui hai, garam hai, hot hai. So it has both the meanings, tapeli, tapeli che. So English version will be utensil, is a utensil. Ek patila, patila hai. Nothing is wrong in that sentence, hai to hai. And the second meaning is ki wo patila garam hai. So again, there are two meanings, tapeli, tapeli che. Now this is from Marathi. Mitracha vina udhyane konas anand hot nahi. So basically it says that without mitra, you cannot have anand, entertainment, in udhyan, in park. So in first sense, friend, I mean, you will not get any entertainment without a friend in a park. Okay, fine. Second is mitra means sun. So if it is cloudy and if it is raining, you will not have any entertainment, you will not have any enjoyment in a park. You need to have clear sky. So that is the second meaning. Mitrachya vina udhyane konas anand. So this is another example again from Marathi. Shri Krishna Navara me Navari. Shishupal Navara me Navari. So here it is Navari and here it is Na dash Vari. So again at this point it should remind you of pre-processing steps. Whether to consider hyphenated words with hyphen or without hyphen. Because here if you are not using the hyphen, it will change the sense. Navara is like Dulha, sort of groom. And Navari is like bride or wife. So when Shri Krishna is wife, Rukmani says, it is not mentioned here, but Rukmani says that I am wife. But if Shishupal is the groom, then I am not going to marry. Then I am not going to be his wife. Navari. So I will not marry. Shishupal Navara, me Navari, Shishupal Navara, me Navari. And then we have some funny statements. So that was about figures of speech. I was not going in detail. Otherwise, you can say that, okay, this is Umagalankara and this is Alankara and that. Okay, so farmer build dies in house. This is a funny statement. And this is, in fact, a very standard example. And headlines of news articles also. So name of a farmer could be Bill, who dies in a house, or the farmers, let us say, bill of reforms, the act And this is quite relevant as on date because we have already a bit of agitation going on in some northern parts of the country. But this example has nothing to do with that. This is just a coincidence. My disclaimer. So farmer bill dies in house. Another is safety experts say school bus passengers should be belted. Oh my God. So safety experts say that school bus passengers, they should be belted. That means you should hit them with a belt. This is one meaning. And second is they should use the seat belt. This is the second meaning. Third is drunk gets 9 months in violin case. So violin case means the court case of violin, and the second one is that box. The coffin, for example, in which the drunk gets 9 months punishment. Girl hit by car in hospital. Now there is a girl who was hit by a car and she is in hospital. Or there was a girl in hospital and she was hit by car. Iraqi had 6 arms. So I'm not going to explain this. This is self-explanatory. Head means chief, and or could be the part of the body. And arms could be the physical arms of our body or could be the weapons. Lung cancer in women mushrooms. So I don't think that we have gender of mushrooms. Do we go to market and say, please give me male mushrooms or give me female mushrooms? But you should not be laughing on this statement because so that is the point, because we human beings can understand this. So that is why this is a challenge from NLP perspective. But a machine will not understand. Teacher strikes idle kids. Again, this is too much. So kids were idle and teacher was striking them, teacher was hitting them because they were idle. The second meaning is teacher strikes. Teachers are on strike and the kids are idle. Visiting neighbors can be a pain. So when you visit your neighbors, it can be a pain for you because they are not entertaining you, or your neighbors are visiting you and then they create hell of problem for you and therefore they are a pain. So visiting neighbors can be a pain. And a few more examples of funny statements. ABC wins on budget, but more lies ahead. Now you can replace ABC with name of any prime minister or any finance minister who wins on budget in house. And again, when I say house, again, it is you need to have that pragmatic context. I am talking about the parliament house. But more lies ahead. So there are more things to come. That is one sense. And more false statements. Lies means lie means something which is not truth. So ABC wins on budget, but there are more lies which are ahead. Squad helps dog bite victim. So I am not, explaining each one of them. Most of them are self-explanatory. Stolen painting found by tree. This is one just I explained. 2 Soviet ships collide, one dies. Now, who died? Ship died or a person died? Juvenile court to try shooting defendant. So which shooting? Drunken drivers paid 1,000 euros in 2018, and instead of euros, you can have rupees also. In 2018, you can have 2020 also. So, did the police pay the drivers because they were drunk? So they paid them 1,000, or did the drivers pay to police? So, is it from police or to police? That is the question. An ambassador is an honest man who lies. So, lies staying and lies speaking false statements abroad for the sake of his country. And actually, for this sentence, both of these sentences are correct. In a way, if at all we assume that ambassador is lying outside his or her country. And now this is about translation and transliteration. So this is in Gujarati. Lage to tir, nahi to tukko. And we have Hindi version also. Lag gaya to tir, nahi to tukka to hai ye. And we have a Punjabi version also. ऐसी करनी है ना कि लग गया था ठीक है निशानी थी लग गया नहीं तो तुक्का तो लग ही गया नहीं so it has I mean and that also gives you the beauty and richness of Indian culture and languages where you have similar idioms in multiple languages. So what I did was lage to tir nahi to tukko. I just used this idiom of Gujarati on one of the online apps. I will not prefer to name it, but the most famous and most prevalent one on internet. And okay, from research and academic perspective, I can share I used Google Translate. with all due respect and acknowledgements to it. And this is what it gave me. And this is on the point and on the day when I searched it. Today it might have changed. So it gave me तीर जैसा लिख. So this is translation by Google Translate from translate.google.com from Gujarati to Hindi. And then I translated it. You know, you have those two arrows in translate.google.com. So from Hindi to Gujarati, Gujarati to Hindi. And then I translated it back. So it gave me तीर जो वो दिखाए छे कि नहीं. Ideally, it should have given me लागे तो तीर नहीं तो तुक्को back. And then I again translated. And this time it gave me तीर इस तरह दिखता है या नहीं. तीर जैसा लगता है या नहीं. तीर इस तरह दिखता है या नहीं. So it itself, you know, keeps on changing it. And again I translated it back into Gujarati. शू तीर आना जैको दिखाए छे. Back into Hindi. क्या तीर इस तरह दिखता है. See, each time it is changing. So in a way, it proves that it is not that established and that mature. And then I finally translated into English. So it gave me looks like an arrow or not. Now it has completely changed the sense. And try this, which is the transliterated version. If you remember, we talked about translation and transliteration. If you try this and it gives you महसूस करेंगे क्या तीर छोटा नहीं है in Hindi, and this is its exact expected outcome or meaning. लागे तो तीर नहीं तो तुक्को. If it's bang on the target, it was deliberate. If it didn't, it was not. But I was not able to get this meaning. So after figures of speech, after translation, after transliteration, and all of these research challenges from NLP perspective, next we come to idioms and proverbs. Because specifically for machine translation systems, you know, when you translate from one language to the other, idioms always create a problem. And in fact, they are responsible for reducing the efficiency of machine translation systems. So in Hindi, we have something called Adjal Gagri Chalkat Jai. And if you write this in Google, this is its exact Hindi version, Adjal Gagri Chalkat Jai. This is the translation that I got from Google. The waterless sky can spill. उसको मैंने फिर हिंदी में ट्रांसलेट किया. So I translated it back into Hindi and it gave me पानी रहित आकाश फैल सकता है. And this is the actual meaning. An empty vessel makes more noise. And see, the difference here is if you write Jai with single A, and if you write Jai with double A, the things change, because here it provides Ajal Gagri Chilka Jai. Here, see, this A and this A, it also changes. And this is the correct meaning, and empty vessel makes more noise. I got this meaning when I used this version. So, have you ever bothered to write single A or double A to get the correct meaning? And here is the difference. If you write single A, it gives you this part. If you write double A, it gives you this part. So this is the NLP perspective. In fact, continuing with the same example, we generally write "aap kaise ho." So we should, in the transliterated form, we write "aap kaise ho." But just wonder, "aap kaise ho" or "aap kaise hain." So again, it will make difference. आप यहाँ आओ. Now, आओ, will you write like this, आओ, or will you write like this with a double A? Aadhaar card, Aadhaar. Do you write Aadhaar like this, or do you write Aadhaar with double A? So that makes all the difference from NLP perspective, and person like me keeps on observing this. Okay, moving further from idioms and proverbs. We have literal translations also. So it is not so that Google is always giving these type of incorrect results. It many times gives correct versions also. But then you have to be specific about those about those single A, double A, and so on. So ant bureka bara, bureka bura. Literal meaning is ant bad, bad, bura bura ant, which again when translated bad. and actually it should be evil begets evil. Don't beat around the bush. Jhadi ke aaspas mat maro, which is incorrect. Get to the point should be the correct version. Similarly, you have more literal translations. Don't throw the baby with the bathwater. This is an English idiom. And this is what I got from Google. Snan ke saath bachche ko na fenki. And this is its exact correct meaning. Don't discard something valuable while getting rid of something worthless. It takes two to tango. Very famous idiom. यह tango के लिए दो लेता है, which has now nothing to do with the idiom. The correct is rarely can one party be blamed entirely. उसका हिंदी वर्जन भी है ना, ताली एक हाथ से नहीं बजती. So basically that is the meaning. It takes two to tango. So the spirit is willing, but the flesh is weak. This is very famous example from Russia, because it was supposed to be translated in the Russian context. So that is where context becomes important. Now, if you read this sentence, you will immediately come to know the spirit is willing, is sort of saying this was part of their religious discussion. Spirit is willing means आत्मा तैयार है, but the flesh is weak. मतलब शरीर साथ नहीं दे रहा. This was its meaning, and this is what it got. The vodka is good, but the meat is rotten, because it took spirit for vodka because it was Russian context, and flesh it took for meat. And just imagine it was in the religious context, and the meaning completely got distorted. And in fact, I have tested this many a times with Google, and not just Google. I mean, I am not against it. It is an excellent application of NLP, and researchers are doing a really, really great job. But this is true for all available translation engines. And the point here that I am trying to emphasize is that this is a challenge from point of view of NLP, not for a specific organization. So the vodka is good, but the meat is rotten. It took week for rotten. Always put your best foot forward. So that's what I am doing today. I am putting my best foot forward for this presentation. And this is what literal translation. So that is why I am saying that this literal translation has to say, हमेशा अपना सर्वश्रेष्ठ पैर आगे रखें. Now, which one is सर्वश्रेष्ठ पैर? If there are two, which one is the best? The exact, actual, correct meaning is try as hard as you can, or give your best. A cat has 9 lives. एक बिल्ली के 9 जीवन होते हैं. Literal translation. Exact meaning: cat can survive seemingly fatal events. So these are all cases of literal translations. Now the question is exact translation possible? And answer is yes. And see, Google and in fact all other organizations, be it Microsoft, be it Facebook, be it all the other organizations, they are using NLP, and they are using NLP like anything. Data science has been called, rather data scientists has been called the sexiest job of the 21st century by Harvard Business Review. And in fact, that was the moment which, gave it to hype, data science. And data science makes excessive natural language processing, NLP. And I am not saying so because I am a person of NLP. Honestly speaking, I am like neutral. I work in various areas, be it NLP, be it artificial intelligence, be it others also. But you should know that NLP is very, very important, because when it comes to evaluating the reviews of the customers, reviews about the products, when it comes to the products like Siri, Alexa, Cortana, and when it comes to artificial intelligence. So in all of these areas, you will naturally, you can think about sentiment analysis. You can think of, now people are working on sentiment analysis based on the images. And then sort of fortifying it with the text which was written. So it will give you still better results. So the point that I'm trying to bring home to you is that NLP is very important. Okay, coming back to our discussion, is exact translation possible? Answer is yes. Make hay while the sun shines, and this is what Google gives. Very Ganga mein haath dhona. Perfect. Where there is a will, there is a way. Jahan cha wahan raha. And all of these algorithms, be it with Google or be it with other organizations also, they are learning and they keep on updating themselves. And you might have seen, I don't know whether you have observed it or not, but sometimes when they are very sure that, okay, this has to be translated this way only, they will give you a badge like this. I don't know what shape they are using, but they are giving you a badge to indicate that this is the exact correct meaning and it is known. They are not making a chance. They are not making a guess. They are not taking a chance. Two heads are better than one, except Halido, and so on. And now we finally come to mistakes. This is going to be the last slide, and after that, the session will be over for questions and answers. I thought that before I wind up this discussion, let me just uh, give you a glimpse of the mistakes that becomes a challenge for NLP. Autocorrect has become my worst enemy. Now, just see, anima is something completely different. It should be enemy. I study in West College, and this is what I have seen many students write. And honestly speaking, I am receiving many CVs also for job applications and others, and literally people have written that I studied in that college. Now, college is completely different. I just went to an emotional wedding, even the cake was in tears. So now these tears should be TIERS actually, and not in tears. The cake was not crying or weeping just because it was emotional. Reading while sunbathing will make you red. So I have not touched on that area of homonyms uh, and then there are n number of other categories. But red or RED red or READ red. I have felt the now this is something very very common. Particularly, I have seen those students and while I was assessing their answer sheets who are learning Excel, they are using these type of words. I have filled the sheet or shit, whereas actually it should be this one. I got 200 out of 100 marks. Now this is very common. See, all of these things become challenge from NLP perspective because if you say I have filled the sheet, machine will simply translate it literally. It does not know that you are talking about Excel unless you make that machine understand that context that it is Excel and the machine should then automatically correct it. Uh, it should be I got 100 out of 200 marks. Last year I will complete syllabus in time. Now, this is something that I have written based on one of my experiences in interview where a candidate, I asked that candidate, I was chairing that panel and I asked that candidate, do you complete the syllabus in time? And the candidate said, last year I will complete syllabus in time. Now I got confused as a person of NLP. Last year is past tense, will is future tense. So what do you mean to say? And now this is again a height of it. What is your martial status? Actually, it should be what is your marital status. So the session is open for questions and discussion. And just to summarize before we start with questions and discussion, let me give you sincere thanks for your patience and attentive listening. And it was like a sort of a roller coaster ride, right from the rationalist approach to empiricist approach to symbolic, non-symbolic, and artificial intelligence, weak, strong. We talked about Rama and Ravana and so many languages, movie songs. So I tried to cover as much as was possible so that I can provide you with a holistic picture of what NLP is. Uh, that's it from my side. Thank you. Over to you.
Thank you.
So, do we have any questions?
Excuse me, sir.
Yeah, Anjal, please.
First of all, thank you very much. It was a really great lecture, and I got to learn a lot about NLP. Actually, sir, it has been over years being a student of electronics. But sir, if like we were talking about the application of NLP in OCR, if it is possible that we take a picture of a circuit, suppose a 555 timer, which has been built around 10 years ago, and then taking the picture from there, reading out the alignment of the structure and the ways the wires have been arranged, detect the working of the design and the possible issues that can be there with that design. Is this a fair, is this a possible area of research, or it's just an impractical idea? I've not been sure about it.
There was a little bit of disturbance in what you were saying, but what I was able to get was that you were asking that if you take a picture of electronic circuit and you want to get that circuit in the actual circuit format instead of an image. Is
Like,
it what
suppose we can take a picture and get a simulation out of it, if that's possible.
Well, there are two parts to this question's response from my side. Number one, technically speaking, obviously, yes, it is possible because if you have an image, you can convert it and you can process it because basically the image has standard components, and those standard components could be resistors, could be transistors, could be wires, jumper cables, and so on and so forth. So all of these components are standard. In fact, you can extend it further to the extent of saying that, for example, if you are using a cable for earthing, you can have it in green color. So obviously, all of this can be done. And as far as the second part of your question is concerned, whether it is possible or not, I will definitely say yes. And if that area has not been worked in, I think you should definitely work in that area. See,
And so,
the things that we are seeing today, 5 years back, 10 years back, people used to say whether it will be possible or not. So something which is in your imagination today is going to be the scientific advancement of tomorrow. So definitely it should be worked on.
And how much do you think will it be feasible? Like, suppose we talk about NLP, still there's so much of development going on, and as the examples that you've suggested, there are a lot of errors possible. So, something like this, will it get into something industrial, or it will just be a toy for like you have so many simulation softwares that used for the students to study, but not for the industry because they're not feasible enough.
I don't think that it will be appropriate to say anything on this question at this moment.
Transaction formatting, thereby guaranteeing the security of data.
I don't think that it will be appropriate to comment anything on this statement at this moment because, see, that is what is called research. So, research is something where you are working in a direction and there are challenges. That is why this area has not been worked. But you can't just imagine and assume that, okay, because there is a probability that it is not going to be successful, therefore, I will not work on it. Had it been so, no one will go for research. And it is typically said that in research, even if you fail 100 times, actually it is not a failure, at least from research perspective. I am not talking this from the perspective of your typical examination system. But from the research perspective, if you fail in doing something even 100 times, then you should say that I tested 100 times and I have contributed to the scientific world by saying that these are the 100 ways in which we cannot do this. So it is not a failure. So basically, you are a platform for others to know that, okay, if you have to do this, you have to test something else. You have to use some other mechanism. So as far as your part of industrial perspective is concerned, I think you should work in that direction. And in times to come, personally speaking, I believe that it looks promising. I believe that it has that potential.
okay, sir. Thank you. Thanks a lot, sir.
Any other questions?
Sir?
Yeah.
So that was a magnificent speech you have there, and it was quite nice to hear such such kind of information, which is more linked to our own perspective, our own thoughts. Sir, I have a question like, how can NLP is used to decipher the ancient or not dead languages in the present day?
Okay. See, there are multiple dimensions to this question. One is like you scan some document which is, let us say, 1,100 or whatever number of years old, and then you try to find the characters and alphabet which was used at that point of time. So, for example, even if you go in the Indian old scriptures like Ramayana, if you see the which is written or the ana which is written, it is different from the or ana which is used in the modern Hindi Devanagari script. So that is one. And the second is, and I am very happy to share this, that there are many organizations, non-government organizations, as well as the government organizations, which are working in this direction. I really wonder whether you know about the concept of Unicode or not. But you might be knowing about the concept of ASCII, American Standard Code for Information Interchange. Similarly, we have the concept of Unicode. ASCII happens to be a subset of Unicode. And Unicode supports internationalization, and it has the characters. See, for computer, characters are nothing but symbols. So, ka, kha, ga, and all of those are there. And for the old scriptures of the Indian rendition, the Indian government made efforts, and now they are included as part of Unicode. So, this is one in order to answer your question. Coming to the second application in Pune itself, one of my friends, and in fact, I am very closely associated with that person. One of my friends is working in sort of regenerating the Sanskrit text of an astrological book, and it has very good insights. But the thing is that you need to find people who have, mastery on these multiple subjects. Now, I know astrology, I know NLP, I know computers, I have that mechanism. So basically, I am helping them that, okay, this could be the word which is missing, and this could be the sense, and this is how we can get it. So people are working in that direction.
Thank you, sir. That was a quite informative session.
Audience, if you have any more questions on this informative session, listening to your talk full of examples in which you have given, so enlightening. We are to have this session today, and I think it was online on YouTube also, and many viewers were there. So it will be there. It will remain on that YouTube channel. Yes. I think no question round almost over. So Tushar, you can conclude this session by giving your concluding remarks.
Yes, sir. Sir, thank you very much, sir, for this magnificent tutorial. And it was quite a load of information there. And actually, sir, the point is that we all recommend to take part in this particular field of research, as it is quite interesting and more and more advanced technologies are being made using the NLP and other techniques as well. So it was quite a honor and pleasure from listening to you, and thank you very much, sir, for this honor.
Thanks for the invitation, and thanks for giving me an opportunity to speak about NLP. And as I said in the beginning also, if you ask me to speak on NLP, I can speak for centuries and centuries. Still, I will feel that the time has, fallen short. So I believe that I was able to at least bring the gist of what NLP is, how it started, and where it is going. Thank you very much for giving me an opportunity, and wish all of you very good luck for your research ventures as well as for your academic ventures. Thank you. Namaste.
Thank you so much. Thank you so much.
Thank you, sir.
Thank you. Start at 1:30, huh? Tushar?
Yes,
Uh,
ma'am.
And
Ma'am.
who are the technical team for that?
I, Anchal Katyal, and my friend Bhavya.
Okay. So need to join before time so that facilitate everything. Huh? Facilitate.
Yes, ma'am.
Okay.
Yes, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Hello. Hello. Hello.
Hello. Um, Hello.
Hello.
Yes. How may I
Yeah.
help you?
Yeah. Actually, my tutorial is supposed to start at 1:30. It will start on time, no?
Yes, sir. I apologize for the delay for answering you, but it
No
will
issue.
surely start at 1:30. Are
Yeah.
you
Yeah.
facing
I'm
some
here
other
only.
problems, sir? Some
No.
technical issues?
No
Are
issues.
you able to share your slides, sir?
Yeah, I'll just share it and show you.
Okay, sir.
But I think you have to make me presenter for me to share.
So I'll just check about the sharing thing. Just a moment. I'll just let you know. I'll
Yeah,
just
the
talk to
host has
my
to make me a
coordinator.
presenter. Yeah, yeah.
Yes, sir. I'll just check that. Okay.
जी. Thank you, sir. Um, sir, excuse me, sir. Excuse me, Dr. Ravi Kumar, sir, are you there? Yes, sir. The slides are visible. So can you hear me? Um,
I can hear you. I can hear you.
yes, sir. The slides are visible.
Sure.
Thank you, sir. Thanks for checking.
Sure. ನಿಂದು ಇದಿದೆಯೇನೆ ಶುಭು ಇನ್ನೊಂದು ಸ್ಕ್ರೀನ್ ಯೂಸ್ ಮಾಡ್ಬೋದಾ ಈಗ ನಿಂದು ಇನ್ನೊಂದು ಸ್ಕ್ರೀನ್ ಇದೆಯಲ್ಲ ಬೇಗ ಅವನಿಗೆ ಕೊಡು ಇವಾಗ ಅದು ಇನ್ನೊಂದು 30 ಮಿನಿಟ್ಸ್ ಇನ್ನೊಂದು 15 ನಿಮಿಷ ಶುರು ಆಗುತ್ತೆ ಅದು ನಿಮ್ಗೆ ತೋರಿಸಾಕ ಅದು ನೋಟ್ಸ್ ಮಾತ್ರ ಯಾವಾಗ ಕಾಣುತ್ತೆ ಇದು ಹೆಂಗೆ ಇದು ಇದೆಲ್ಲ ಕಾಣ್ಕೊಳ್ಳೋದಿಲ್ಲ ಇದು ಪವರ್ ಪವರೇ ಇಲ್ಲ ಈ ಪವರ್ ತೆಗೆದ್ರೆ ತೊಂದರೆ ಆಗುತ್ತೆ
Okay.
ಇದು ಆಲ್ರೆಡಿ ಕನೆಕ್ಟೆಡ್ ಇದೆ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಲೂಸ್ ದ ನೆಟ್ವರ್ಕ್ ಪವರ್ ಅದನ್ನ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಬೇಡ ಬಿಡು ಶುಭು ಇಟ್ಸ್ ನಾಟ್ ದಟ್ ಐ ಡೋಂಟ್ ನೀಡ್ ಇಟ್
You connect this, I will give you the extension cord.
ಎಲ್ಲಿ ಹೋಯ್ತು ಅದು ಕನೆಕ್ಟ್ರು? ಕನೆಕ್ಟ್ ಮಾಡಿದ್ವಿ ಅಲ್ವಾ ನನಗೆ?
ನಿಮ್ಮ ಹತ್ರ ಇದು ಸೀರಿಯಲ್ ಕನೆಕ್ಟರ್ ಇದೆಯಲ್ವಾ? ಸೀರಿಯಲ್ ಕೊಟ್ಟು
ಇದು
USB ಕನೆಕ್ಟರ್ ಬೇಕಾ?
ಇದ್ದಂಗೆ ಇಲ್ಲ ನನ್ನ ಹತ್ರ ಇತ್ತಲ್ಲ.
ಮತ್ತೆ USB ಕನೆಕ್ಟರ್ ಬೇಕನ್ಸುತ್ತೆ ನಿಮ್ಗೆ. ಈ ಕಡೆ ಇದೆ ಇದು ಫಂಕ್ಷನ್ ಇದೆ ಇಲ್ಲೇ ಇದೆಯಲ್ರಿ?
ಓ ಇದೇನ ಕೊಟ್ಟಿದ್ದೀನಿ ಕರೆಕ್ಟ್. ಈಗ ಅನ್ಕೊಟ್ಟಿದ್ದೀನಿ. ಈಗ ಇಲ್ಲಿ ತೋರ್ಸತ್ತಾ ಅದು ಆಟೋಮೆಟಿಕ್ ಆಗಿ? ಎಲ್ಲಿದೆ ನೋಟ್ಸು? ಇದಕ್ಕಿಲ್ಲ.
ಇಲ್ಲಿ ನೋಟ್ಸ್ ಬರ್ತಾ ಇದೆ ನಿಮಗೆ.
ಓಕೆ, ಥ್ಯಾಂಕ್ಸ್.
ಸೊ ಬಿ ಕೇರ್ಫುಲ್.
ಫೈನ್.
ನಿಮಗೆ ಬೇಕಂದ್ರೆ ಅದೆಲ್ಲ ನೀವು ಅದು ಸೈಡಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ.
ಬೇಡ ಬೇಡ.
Good afternoon, Professor C.P. Ravi Kumar. Welcome you.
Hello, ma'am.
Hello. Yeah.
This is Angel. Actually, sir had joined around 1 o'clock, and we've just welcomed him and made sure that he has no issues with the technicalities. And I think maybe he's at a pause or something like that.
So we will be there. He will be there around at 1:30 again.
Yes, ma'am. Yes, he joined at 1 o'clock. Sure.
Thank you.
Is it fair to? Is it okay that we start at 1:30? Right? We don't
Yeah,
want to.
the session is 1:30 to 3:30 only.
Okay, ma'am. We'll start sharp at 1:30 then.
And next session is at 4 to 6 p.m.
Yes, ma'am.
The electrical vehicles one.
Yes, ma'am. Thank you, ma'am.
Hello, sir. Am I audible?
Yes, you're audible.
Sir, do I have your permission to start the session?
Yeah, please, please.
Okay. So I'll be starting just shortly. First of all, I would like to thank you, and it's a great honor having you speaking at INDICON 2020. I hope it will bring considerable value to the people who attend the conference and to our organization.
Thank you very much.
I'll be starting with the
Should I start?
introduction in a moment.
Okay, sure. So shall I start?
Just sorry for the confusion. Yeah. Okay. So I'll just start with the introduction. After 3 minutes,
Sure.
you'll be just free.
Sure.
Okay, sir. Okay. So basically, the new electronics independence recreates the world in the image of global village. This is a quote by Marshall McLuhan. Automotive electronics, industrial systems, and Internet of Things are a few branches of ever-growing stream of electronics that dominate today's market. With so many systems out there, a single vulnerability is all an attacker needs. Functional safety has become most important as a result, elevating expectations of quality and reliability of the components used in these systems, making verification, testing, and validation challenges which are stronger than ever before. To help us develop greater appreciation for the new endeavors in the area of VLSI testing and verification, we have with us Dr. C.P. Ravikumar, Director of Talent Development at Texas Instruments, India. He is also an adjunct faculty of EE at IIT Madras. Before joining TI in 2001, Ravi Kumar was a professor of electrical engineering at IIT Delhi. He also held a visiting position at the University of Southern California and a position of vice president training and at ControlNet India Private Limited, obtaining his PhD in computer engineering from University of Southern California, ME in computer science with the highest score from Indian Institute of Science, and BE in electronics with a gold medal from Bangalore University. He has published more than 200 papers in the leading international conferences and journals. He has 4 US patents in the area of VLSI test, founder of VLSI Design and Test Synopsis, and was a general chair of this event from its inception in the year 1998 for 15 years. He is author, editor, co-author of over 15 books in the area of VLSI and has contributed to several book chapters. He has served as an associate editor of IEEE Transitions on Circuits and Systems and also on the editorial board of Journal of Electronics Testing, Theory and Application, and the Journal of Low Power Electronics. He has won the Best Paper Award at IEEE International Conference on VLSI Design in 2002 and VLSI Test Synopsis in 2005. He has founded the Bangalore chapter of IEEE CAS Society and was an honorary secretary for 15 years and has served as an honorary secretary for VSI for 6 years. He has served as an ex-com of IEEE Bangalore section from 2017 to 2019. He is a fellow of INAE and a senior member of IEEE. Here to discuss the challenging role of semiconductor verification and test in the modern times, please welcome Dr. C.P. Ravikumar. So you may please start.
First of all, thank you very much for the kind introduction. So it's
You're
a
welcome.
pleasure to sort of share my ideas with you. I have targeted a student audience and young professionals. So if you have any doubts at any point of time, do not hesitate to unmute yourself and ask me any questions that you may have. We don't have to be very formal. I have 2 hours with me, and I hope that at the end of this 2 hour tutorial, you will pick up a lot of new ideas which are prevailing now. There are a lot of you know uh, new research topics that are emerging, and I hope those of you who are students, those of you who are young professionals, will be inspired to sort of work in these areas. Like I said, I would like to thank the IEEE Delhi section, in particular Dr. Prerna Gaur and Dr. Rajni Sharma for inviting me to give this tutorial. So with that, let us begin. So you already heard the abstract of my tutorial, so you possibly know what to expect. So here is a, brief agenda, right? So we are going to, talk about why VLSI design flow is now IP based, right? And how it has brought a lot of challenges, right? And why there is such a stress on semiconductor quality and reliability today, and why there is such a concern about semiconductor security, hardware security. And finally, we'll talk a little bit about how machine learning and AI are being used in the area of test and verification. So that will be the overall agenda of my talk today. See, you may have heard about this term called vertical integration, right? See, today it is not in vogue, right? Once upon a time, maybe many years ago, maybe more than I would say 30 years ago, companies used to have vertical integration, meaning, see, let us take TI as a semiconductor company. See, we have manufacturing capability. Right? We also do, design, right, which includes, you know, you know, and then verification, synthesis, right? We also do our own packaging, and we do our own testing, right? But we do quite a bit of outsourcing today, right? We do work with a lot of different companies, outside companies. For example, let us take EDA tools, right? See, you may not know this, but many years ago, right, these EDA companies really did not exist. So TI would write its own design automation tools or CAD tools for doing things like layout, simulation, and so on, right? But today we work with EDA vendors, right? Similarly, we work with other vendors where we can outsource, let us say, IP design, right? We acquire the ARM microcontroller and microprocessor cores, right, by paying a license fee, and we reuse them, right? So this has become very prevalent in today's semiconductor industry, right? So gone are those days where companies would do their own design of everything that is required. Right? So if you take a modern system on a chip, it has so many blocks, right? It is not uncommon to find several hundred blocks inside a modern system on a chip. You may find some processors there, you may find various kinds of memories there, flash memory, SRAM, DRAM. You may find various peripherals, right? You may have some sensors there. You may have analog and mixed design, signal components, power management. So hundreds of different kinds of blocks get into modern day systems on a chip, and it is not feasible for a company to design all of these right? And then be responsible for manufacturing, packaging, and test, right? It will take too long, right? Make life easier and to be able to uh, sort of bring out products in a reasonable amount of time, companies have switched to a what is called as design reuse, right? Which means we will outsource a lot of these activities, right? And integrate IP, for example, from a number of different companies, right? So we may acquire IP from ARM, like I was telling you earlier, from companies like Synopsys or Cadence. So there are a lot of such companies today which provide semiconductor IP. So IP stands for intellectual property. So these companies like ARM do not manufacture any ICs. They only provide the intellectual property, and anybody can license and acquire these intellectual properties and integrate them into their SoCs, right? So all this brings a lot of challenges, right? There are also companies that don't have their own fab, right? TI has a fab, right? We do have many fabs across the globe, but there are some semiconductor companies which don't even have their own fab. They get it outsourced. So China became a major semiconductor manufacturer, right? Because of these fabless companies. So when you are distributing your activities like designing, verification, manufacture, test across different companies, which may be located in different parts of the world, naturally there will be some challenges. If you have to maintain quality, if you have to maintain reliability, security breach here, right? So let us talk about this a little bit later. So this is what I was referring to as Achilles heel, right? You may know that there was a Greek sort of character called Achilles. This Achilles is his mother apparently dipped him in a holy water of a river to make his body strong. So unfortunately, his heel did not sort of come underwater. See, how they do it is they invert the baby, right? They hold the baby upside down. So maybe the mother was holding the baby by the heel. So the heels were not in water, and as a result, his heels were not strong. And later, apparently, an arrow directed at this Achilles heel killed him, right? So the IP-based design flow that I just was talking about, right? Clearly, there are some Achilles heels there also. There are some gaps there, and people can use that to sort of, uh, you know, hack things, right? And people can use it, in many different ways, as I will explain later, right? So here is a very quick overview of the design flow. There are these four large steps I have mentioned here. So architectural design, RTL design, and verification. This is one, front end activity. Okay, some people refer to this as the front end. Usually, this is the secret sauce of any company. So people like to keep it close to their heart, right? This is followed by logic synthesis, right? And then physical design. Okay, so I have called it synthesis here, but it may require both logic synthesis and physical synthesis. Some people call physical synthesis, the other name is layout. Then you need to extract the parasitics, right? To perform what is called a static timing analysis to make sure that the timing is all good, right? And then once you are satisfied with everything, you will go on with uh, manufacturing. Okay, initially you manufacture only a few samples, and then you validate. Okay, it's called post silicon validation, just to make sure that the product meets the specification, right? You are going to bring about a data sheet and claim that this product offers a certain kind of performance and power. So you want to validate whether that is indeed the case, right? So that is once those samples pass that validation test, right? Then you can go for what is called as ramp or mass manufacturing, and all the packaged ICs are supposed to be tested, right? So once the sort of testing is done, you will find that there are some devices which have defects in them. These are called manufacturing defects, right? And you have to discard those, right? And you have to only supply the good devices, the devices that your test is passing. Those are the ones which you will provide to your customer, right? So that is what is called quality, right? The ability of a semiconductor company to ensure that whatever they are selling, right, they have determined that to the best of their knowledge, it doesn't have any manufacturing defects, and it should work well when it is used in a particular system, right? Now, there is a chance, right, that if I supply, let us say, 1 million parts to a customer, a few of them may end up having defects. Okay, why did they arise? Did I not test these? Did I not test all the 1 million chips? Yes, I did test, right? But remember, the testing can never be exhaustive, right? It is like, many of your students, right? When you took a course, right, the textbook may have like 10 chapters, right? If you got a passing grade in that course, does it mean that all the 10 chapters, you had mastery in all the 10 chapters? May not be, right? You may have not studied a couple of chapters, but somehow you managed to pass the course, right? In the same way, there may be some defects, right, which were not caught by the test, right? It may be because if I really need to go and catch all those defects, the testing is going to be too expensive, right? For example, if indeed, if your teachers have to ensure that all the concepts that they taught you, your exam may be too long. It may be like 10-hour long exam, and nobody can afford to conduct such long exams. Okay. For the same reason, even in the industry, we can't afford to have very long tests. They'll be too expensive to run. So sometimes, some defects will escape, or some defective parts will escape, and the customer makes a contract with the supplier that I'm willing to accept a certain number of defective parts. It may be 100, okay, out of a million, right? So they will say it is defective parts per million. So if I say 100 DPM, that means I'm willing to accept at most defective parts in 1 million, right? And if it is exceeding that number, then there may be a clause which says, there is some compensation that needs to be provided, right? So this one is called the quality measure. The DPM is called the quality measure, right? And we have to maintain very high quality, right? And it is becoming even more stringent now because we are getting into markets like the automotive, right? I'm sure you have heard about the automotive sector becoming a very important sector, right? Even in the COVID 19 period, right? Initially, the automotive sector faced a little bit of a setback. Right? People were not buying any cars, but once the things began to improve, the automotive sector again grew very fast. Right? Transportation became once again a very important thing. Right? After lockdowns, were withdrawn across the world, etc. And once again, the automotive sector became huge. And The other big sector is the industrial electronics sector, which refers to the ability to have the smart factories and so on. So if you are going to have these smart cars which can provide advanced driver assistance systems, or industrial electronics where robots are going to be working in a factory. So the electronics that goes into these kinds of products, they have to be very they have to have, strictly speaking, zero defects, isn't it? No defect can be tolerated, because if the robot has a defect in it, maybe it can kill a factory worker because it may malfunction. Right? Similarly, if the car has a defect, one of the electronics that goes into the car has a defect, it may cause an accident. It may, it may take the life of someone. Right? So as a result, quality in such systems, they don't want, they actually want zero DPM, but zero DPM is a very difficult goal to achieve, right? It will be too expensive, right? And customers may not be able to afford, such low DPMs. So they usually it becomes like a defective parts per billion, right? So maybe they are willing to accept a few defective parts in a billion. So it is very stringent requirement in quality. Right? And to make things worse, see, we want very high quality, right? And we also want very high reliability. Now, what is reliability and how is it different from quality, right? See, even after I sell the part to you, you may be my customer, I have sold you my part. When you start using it, right, that device may have a certain lifetime, right? It is supposed to last for a certain number of years, right? I will only guarantee that it will work well for a few years, maybe 5 years or whatever number of years. And beyond that, I'm not giving any guarantee, because this device is going to undergo aging when you use it. You may also be using it in a sort of a, you may be rough on the device, right? You may be stressing it, right? Because of that, the life may get shortened, right? And it may develop a defect over a period of time. For this, the semiconductor vendor cannot take responsibility. The semiconductor vendor will only provide a warranty period. Okay, and if it fails within that period, then the semiconductor vendor is liable. Otherwise, no. Right? Now, reliability refers to the ability for the part to work without any failures in time, right? At least for the period of the warranty period. Okay, so that is what reliability is. Right? So you can possibly now guess that when we are doing a product which has IPs from a number of different places, where manufacturing may be outsourced, packaging may be outsourced, and so on. Guaranteeing high quality and reliability can be quite a big challenge. Right? So that is what you have to remember. And remember that we have moved to IP-based design flow mainly because we want to save time. Otherwise, if we have to do all the activity within our company, it will take too long, and parts will not reach the customers in a reasonable amount of time, right? And this is an active, okay. The fact that we are buying IP from other companies, in the process we may, then the fact that we are outsourcing other activities like maybe packaging and manufacturing and so on, that may also bring a certain amount of risk with it. And the fact that there are a lot of wireless in our modern devices, that also is a problem because people can steal data, right? In a wired connectivity, stealing data is not so easy, but wireless connectivity, the data can be stolen by somebody, right? And we'll talk a little bit about that. So in RTL design, right? So when I buy this IP from someone, who knows, right? Maybe people have some, backdoors there, right? So what if there is a Trojan there, right? I mean, there is some device which doesn't get activated until later, right? Maybe a little later it gets activated, right? Maybe it waits for several weeks or months, and then it suddenly becomes active and it starts acting as a, sort of it steals data, okay, from you, okay? Or maybe, you have left some backdoors in the test and debug, which allows people to steal data. So this can be a big problem. Similarly, I think I mentioned about hardware trojans. Then there could be, uh, what if you have decided to manufacture it from an external vendor, and that vendor decides to produce extra, right? You only wanted him to produce 1 million copies, but he produces 2 millions and decides to sell the other 1 million, by himself or herself, right? So that can be a problem because your profitability is going to be impacted by these fake products. Then there are people who are willing to steal your design. I mean, they will reverse engineer your product, okay, and produce fake products. Okay, the fake market is a very huge market, right? And unfortunately, it brings down the reputation of the semiconductor company, right? Imagine people are selling something that looks like a TI part, but it is not a TI part, right? So that can be a problem. And also maybe some people are, they are into this recycling industry, right? If you throw away your mobile phones and laptops, etc., there is a industry there which will disassemble the PCBs, recover the old parts, ICs, and they will try to bring it back into the market, right? Now, what is the bad thing? It may be a working IC, no doubt, right? But the problem is it has already lived a life, right? Maybe it was being used for a few years, so it is not going to be. It may develop faults sooner, right? It may not be able to reliably perform its duty and may result in what is called as a customer return, right? So imagine that you go and try to return your IC and then you are told that this was not this was manufactured many years ago and we can prove, right? We can prove it to you that this was manufactured many years ago, right? And maybe you went and bought it in a sort of a market without realizing that it was a fake product or it was a recycled product, right? And then there could be what are called as side channel attacks, right? I will talk a little bit about this later. So testing has to be done in a very secure way. Otherwise, there may be some secrets that are there inside your chip. Maybe there is some password in your chip, right? Or maybe there is some data that you are trying to transmit. Maybe it's a medical device, or maybe there are it's a banking transactions are happening out there, and people may be able to steal that data, right? It may be the encryption key, right? Somebody may steal the encryption key and be able to read all the data that you are trying to transmit. So these are the dangers. So this is what I meant by the Achilles heel. And I think I sort of already talked to you about this earlier. Why is it that we are so concerned about it today? Because of the markets which are emerging. There is the industry market, we call it Industry 4.0. People refer to this IoT today, right? Then there is automotive market, right? And all these have emerged because of the fact that is the growth in the semiconductor segment and growth in various communication technologies, growth in embedded systems, cloud computing, edge computing. So all these have led to this growth in IoT, which has further led to this Industry 4.0 and also automotive. Automotives today, this Internet of Things, right? Car is just one of the things that may be there on the internet, right? And cars may communicate with one another. You may be able to track your car, right? And imagine that somebody can put a Trojan in the car and as a result can gain access to the car completely, right? And start driving that car remotely, right? Such things have actually happened. People have proved that such a thing is possible, right? So there was definitely an incident where the car, was the person who was had no control on the car, right? Somebody else was remotely driving that car, right? Suddenly, that person can even brake the car on the freeway, causing accidents. So it can be a very bad tool in the hands of a criminal or a terrorist organization. Right? So these are the dangers. So as a result, verification and test are going to be really important, right? So if you buy a car from an auto manufacturer, see that person will internally use a lot of electronics, right? Today, a lot of heard that things like a car is nothing but a computer on wheels, or you may have heard that today cars are no more mechanical engineers domain. It is more of electronics or computer engineers domain. Such things you may have heard of, right? And it is, I think, true. There is a lot for the money that you pay to buy a car today. A large amount of it will go towards the electronics, right? And so this guy is dependent on these right? Those who supply these electronics, right? And this person in turn, right, depend on various component manufacturers like TI, which supplies IC parts, and maybe other components like capacitors and so on, which may also be important. Right? So the security, in turn, he relies on this guy, right? And this guy in turn relies on this guy. So there is a sort of a dependency here. So ultimately, you see, this guy is the one who is selling, the auto manufacturer is the one who is selling the car. And if there is a problem with the car, and if there is a lawsuit that is filed, right? Ultimately, when the investigation takes place, right, they will have to figure out what really went wrong. Was it something wrong here, right? Or was it a fault here, or was it a fault here? Right? It may take a lot of time to figure that out. A lot of debugging has to happen to figure that out, right? But ultimately, right, somebody has to take ownership here. Right? So this is called quality protection as a service. Okay. So today, the auto manufacturers, when they buy components, they are trying to put pressure on these guys to make sure that you must partner with us to sort of provide quality, and these guys are instead in turn putting pressure on the semiconductor manufacturers. Okay. So today you must be willing to share a little bit of data about your manufacturing practices, etc., with these guys. They should be able to share their data with us. Okay. So you can have a hard brick wall here and say, you cannot ask us how we are producing it. Okay. This is how it was before, but today these guys expect you to share some data so that debugging is possible, so that everybody can be comfortable in owning up their roles. Right? So the role of testing today, okay, once upon a time, testing was only meant for separating the good parts from the bad parts. Okay, so we will throw away the bad parts and we will only sell the good parts. So it was more of a quality, just to preserve quality. But today, it is also meant for reliability. Okay, so reliability testing is also quite important today, and also security. Right, it is a way to look for security and a way to debug the failure. Right. So there is a concept called functional safety that I have mentioned here. So you should understand what. See, is because of some bugs which are left over in your product, right? It may develop a functional, safety issue, meaning it no more performs the intended function. It may not, adhere to whatever data sheet that you are providing, right? So there may be a functional failure, and that is actually called as a functional safety issue, right? So it happens because of maybe either a bug or maybe because of a fault that occurred. Maybe you may know that there is if there is a lot of radiation, right? For example, at very high heights. Okay, if the place is located at a very high elevation, there it is susceptible to more radiation, right? Similarly, sometimes there is alpha particles and so on. So they may occasionally cause a temporary malfunction. Okay. So you may have noticed this yourself. Sometimes your laptop will suddenly stop working, right? And nobody knows why, and you have to reboot it. Okay. It could be because of a software problem, right? But there is also a chance that it may be because of some, these alpha particles and so on, right? It may be coming from outer space, or it may be coming from some, packaging. There may be some lead, etc., in the packaging, and occasionally it may have some radioactive, radioactivity, and it may go and cause an event upset. It's called as a event upset. A flip flop, it may change state. Okay, out of the millions of flip flops that may be present, maybe one of them, decides to change state. Right? And it may not be observed depending on what activity is happening at that point in the chip. This change in state may or may not be noticeable, right? But there is that small chance, however small it is, that that may cause some malfunctioning. Okay, so at that point of time, if you want to maintain safety, right? If you want your device or your hardware to be ready for this kind of a malfunctioning, then you have to produce what is called as fault tolerance, right? It should still produce the correct output despite having some sort of a fault. So, for example, you may have heard about memories, right? See, the memories that we use today, the RAM, SRAM, See, if it is a application like cars, right? We all know that when we write data into a RAM, right? There is this chance of event upsets that are occurring. The amount of charge that is stored has become smaller and smaller because of the scaling, right? So a small radiation, can actually cause one of the bits in the RAM to change state, right? So how do we deal with it? In memories, it is possible to check for error correction, error detection. Okay, so you can put additional hardware to detect errors and also maybe correct errors. So these are called ECC RAMs. Okay, error correcting code RAMs, right? So that will require more area, right? It requires error detection and error correction hardware additional, but it may be necessary if you have to use some sort of a tolerance. Okay, for talk a little bit about hardware security. Right? Feel free to stop me and ask questions. No problems, right? So I have been using the word testing. Okay, and in the case of semiconductors, right, there are lots of different kinds of testing that are carried out, and I'll give you a very quick overview here. So one thing we do is we do what is called a wafer acceptance test, meaning, see, remember that we produce a large number of chips in one die. I'm sorry, one wafer, and then you know uh, the dies are separated or singulated. They are packaged and then they are tested. Right, that is how it works. So before we go and do a sort of packaging and all that. See, packaging is very expensive. Right? So imagine that you are spending a lot of time to a lot of effort and a lot of cost on packaging, only to realize that those were bad dies. They were bad chips. Okay? So your cost of packaging was wasted. So it will be great if we can figure out if the die is good or bad even before packaging. Right? So people do conduct certain tests at the wafer and the for sorting, and they ink all the bad ones. So if there are some bad chips, okay, they are marked, okay. And if too many of them are defective in the whole wafer, that means the whole wafer has a lot of defective parts. So we throw away the whole wafer itself. Okay, that way, we can save the cost of packaging. Okay. So you can see that testing costs a lot of money, but it can also save a lot of money, right? If you are doing a good job of testing, then in the long run, you will actually save. Right? So these are the sort of basic kinds of tests, and after packaging, these are the kinds of tests that you typically apply. See, there is one kind of test for digital devices called a stuck at fault test. Okay. So you want to know whether a particular node behaves as though it is stuck at logic 0 or stuck at logic 1, okay, because of some defect. Okay. So this has been a very popular uh, fault model, okay, and it continues to be popular even to this day. And people want as close to 100% coverage of these faults. Okay, you may be surprised that you cannot always get 100% fault coverage of even stuck-at faults. Okay, so some faults, unfortunately, they are untestable. Okay, you cannot generate a test for them. So nobody can ever get a 100% fault coverage on stuck-at faults. We may go very close to 100, right? And if you are not able to quite make it up to 100, that means you are potentially leaving some quality behind you. Okay, so there is always a small chance that those faults that you did not cover, they may have occurred in the chip, right? Then there is a transition delay test. Okay, what that means is, see, in the modern ICs, right, where speed is very important, right? You, today we have chips that work at gigahertz and so on, right? So if you have clock periods, right, there may be some nodes which don't have a permanent fault. Okay, there may be a wire out there which does not have a stuck at 0 or stuck at 1, but it is slow to transition. When it has to go from 0 to 1, it takes a longer time than required. Okay. So if it has to work at 1 gigahertz, maybe the in a 1 gigahertz machine, right? If the chip is supposed to work at 1 gigahertz, that means you just have about the clock period is only 1 nanosecond, isn't it? So in that 1 nanosecond, a lot of activity has to happen, right? Many signals may have to change state from 0 to 1 or 1 to 0. So the available time for every gate may be fractions of a nanosecond. And if a particular gate for some reason is slower, then the device will not be able to function correctly at the speed at which you want it to perform. So that is called as delay testing. So we have to apply extra tests to check whether indeed this device will work correctly at the intended speed. Okay. Then there is also something called as testing means, see, these are called structural tests. Okay, because you have to have the complete gate level description of the circuit in order to be able to generate tests. If you don't have any idea of what is inside the chip, right? If you only want to know whether the chip is good or bad based only on the functionality description, okay, I don't know how it was constructed. What is whether it has NAND gates inside it, NOR gates inside it, how they are connected. Suppose I have no clue about all that, right? I only know that it should behave in a certain way. Then I call that as a functional test. Okay. So these are important, especially when it comes to things like microprocessors and so on, right? So some little bit of functional. There was a time long ago when only functional testing was done. But people realize that they are very difficult and there is no guarantee that, how many functional tests can you possibly run, right? Today, the devices that we make are so complex that if I ask you to start writing functional tests, you may come up with so many of them that it will take too long to test for faults. Okay, and I won't know when to stop. Okay, how many functional tests should I run? 100,000? Right? I have no idea. So today, all number of functional tests are done. Confidence, right? The rest structure, right? And as a these are considered in the modern situation where we have autonomous vehicles and so on. So they are I have mentioned two other things here: test compression and built-in self-test. So see, unfortunately, today's devices are very complex. They have tens of millions or hundreds of millions of gates in them. And they have a lot of memory inside them, right? As a result, if you try to, apply so many tests, right, it takes a lot of time. It takes a lot of time, and people are trying to figure out how we can reduce the test application time. Okay. So people have invented a sort of a technology called test compression in order to reduce the amount of test application time. Okay. It's a big topic by itself. I don't think I should cover that today. Just understand what test compression is all about, right? It's a way to sort of, you know, reduce the amount of effort involved in, applying tests, okay? A related technology is called as built-in self-test, okay? See, what is built-in self-test? See, when I sell a part as a, I'm from TI. Now, TI is, let us say, trying to sell parts to the customer. So, TI has a fab. Okay, in the fab, there are also these testers, right? Testers are very expensive, cost millions of dollars, right? And of course, I'm going to test them and release them into the market. The customers purchase these ICs, right? But what if the customers have to repeat those tests? Okay, you may ask why. Why would the customer be interested in doing that? I'll tell you why. Because suppose my customer is a one who uses it inside a car, right? Now, a car has a long lifetime, right? Many of us don't change our car for maybe 10 years or something like that, right? Now, our ICs, right? See, we may not be able to give them such a guarantee, right? What if somebody wants to use it for 15 years, right? So the best way is frequently test those chips while they are being used in the car, right? To see whether they need to be replaced. Okay. So that is how the you know uh, that is a assumption that is made that these devices are frequently tested. Okay? But how do we test them, right? Because this small IC, right, which is just a few by which is inside some big PCB, which is buried inside the car. And how do you test it? When we were selling it, we had this whole setup for testing it, right? But now, unfortunately, there is no tester there, right? So as a result, we may have to have a capability called as a built-in self-test, some extra circuitry that must be added for generating these tests and so on, right? So that is called as BIST or built-in self-test, right? So these are now mandatory, right, in cars and industrial electronics and so on. In other applications, we may not want to add built-in self-test because BIST is also going to cost more in terms of area, right? I have to add extra area. It may also take up extra power and so on. So it is something that manufacturers are not too happy to add, right? In the kind of markets, automotive and so on, it becomes necessary, right? So this slide, which I have borrowed from Cadence, right, is an excellent slide, right, which explains these three concepts very well. See, if you take a part, right, and look at its lifetime, it usually has this bathtub curve. Okay, this is the famous bathtub curve. Okay. What does it mean? See, this on the y-axis is the failure rate, and on the x-axis is time. So when I release any part, whether it's an IC or whether it is any that I'm selling, see, in the early days it will have a high failure rate. Okay, this is known as the infant mortality period. Okay. Just like a newborn baby is very likely to fall sick. Okay. So the sort of failure rate is high for young chips. And then once that infant mortality period is gone, you see, it usually performs well. The failure rate is low. But as the chip ages, okay, as the chip ages, there are a lot of aging factors inside chips, right? You know, you know, there may be various, device, phenomena, right? For example, your carriers, electrons are, they are hitting the, the collectors at a very high speed, right? So that itself could be one, you know, uh, aging phenomenon. Right? That's just an example I can think of, right? So there are many such, it's called hot carrier injection, HCI, right? So HCI could be one aging phenomenon. Like that, there are many such aging phenomena. The threshold voltage, CBT, you may have heard about the threshold voltage of a MOS transistor. Because of charges that get trapped inside the gate, right, over a period of time. So that the threshold voltage may start changing over a period of time, right? So these are all aging phenomena. So the failure rate will again slowly begin to increase, and in a really old part, the failure rate will again go. Okay. So in the traditional to this part. See, at the time of selling, I want to make sure that there are no failures. Okay, I'm not selling a bad part. But I'm worried about this part, the reliability part. Then I must, design for robustness, right? And I must also think of adding built-in self-test, etc., in order to, avoid, reliability issues and things like that. Right? And finally, the part may become, so old that it starts wearing out. Okay, and at this point of time, it may even develop some faults. Okay, and if it has to continue to operate correctly, right, then we must build in extra features. Okay, we have to build in fault tolerance and things like that, right? So these are the three things that you need to fully understand: quality, reliability, and functionality. Okay? So it's a good explanation that is provided by Cadence. So I think I mentioned this already. Testing is expensive, as you may have guessed by now, right? But in the long run, if you don't test, see, it's very tempting, right? To say that, hey, we have a good process here. We will just test a few parts, right? Suppose we are making 1 million. We can just sample a few devices and just check that they are all good. And then, we can conclude that, if these are doing well, so must be the others. So it's very tempting to do such things. But unfortunately, it doesn't work that way, right? You may have major problems if you end up selling bad parts, right? So, see, for example, here, I have taken some data from McKinsey, right? If you recall in automotive, right? Apparently, it costs anywhere from millions to even billions of dollars, right? So, for example, these are the reasons for recall. See, take this one: wheel cap painted with wrong color. This is no big deal, right? But unfortunately, they may have to recall, right? That may cost a few millions of dollars to them. Or let us say there is a sharp edge of some switch. There is some light switch or something like that. It is a very sharp edge. It may cause some injury to the person who is using, and that may cause somebody to go to the court of law. It may result in some, lawsuit and damages and so on. For this also, they may recall. What about this one? This is even most dangerous. Passenger is unable to release the safety belt. Well, this is not life-threatening, but it is still a problem. Finally, there is engine catching fire. That may cause a huge furor, right? It may cause bad press, right? And media is definitely going to give a bad name to that manufacturer, and it may cause that manufacturer to lose a lot of revenue, right? So as a result, if such incident occur, you have to debug what was the real reason, and to protect your reliability, automotive manufacturers must share. I mean, they would like to share the responsibility with IC component manufacturers. So, which is why today, if you come and join TI and you are working in this area of automotive electronics or something like that, there are some mandatory trainings that you will have to take. Okay, things like failure mode analysis, FMEA, all these are mandatory for people. So we have to show, the manufacturer will ask whether people who are working on these parts have been adequately trained. What are you doing in order to make sure that you are providing us high quality parts? What are you doing in order to do reliability parts, right? So it is expensive, right? So there, but at the same time, it is creating new jobs. It is creating new opportunities for people, right? So that is a good part for students. So I think I have mentioned to you already what is field testing. Field testing means, see, the testing that happens on the test floor in TI. See, that is floor testing. Okay. But when it goes to the customer and the customer start using it inside some part, maybe it's a cell phone, maybe it's a car. If you want to test it while it's still in operation, we call it as field testing. And some people also refer to it as online testing, because even when the device is being operated, we don't want to see, there are two types of testing. Offline means you may have done some offline testing of your PC, right? When you boot your PC, sometimes the PC says, diagnostics, right? That is sort of, at that time, the PC is not doing its usual job, right? It's only testing itself. But online testing means it continues to do its usual duty, but at the same time, it is being tested, right? So this is going to be important in the new developments or industrial. Similarly, if you are going to integrate, see, more and more analog is getting integrated into test chips, right? So there are E to D converters, D to A converters, right? And a lot of other analog components are getting integrated into the same chip along with digital. So you have to think of how to test that analog. That's also a big challenge today, research challenge. So people are trying to use things like loop back test. What is a loop back test? See, you have ADC and DAC, they perform opposite functions. So you may want to start with some signal, convert it into maybe digital, and then digital is converted back to analog, right? And then you compare whether you got back what you started with, right? If you don't get what you start with, there is definitely some issue. So that is called as a loop back test. Then for all the memories that are there inside, you need to have built-in self-test, and you have to have ECC memories, like I told you. Not everything can be made into ECC memory, it will be too expensive. So the designers have to select which are the memories that must be put into ECC memory, right? And there is something called as logic best. The logic has to test itself, and that is becoming very important. People are beginning to use machine learning in testing, right? For example, automatic defect classification. See, I told you, right, this is a wafer. Right? Here is a wafer. And I have inked it. See, the yellow ones are the bad parts. Okay, the blue ones are the good ones. Right? an expert looks at this picture, right? And that expert, because of the experience, is able to sort of guess which are some potential process problems which may be resulting in this pattern of faults. Okay. This comes by with experience, right? So they may look at the sort of pattern here, and they may be able to diagnose, what could be wrong with the what could be wrong in a process cell. Okay. So clearly, this is a thing that your machine learning can do. Right? If you can train a neural net, right, it may start helping us in automatically classifying. Right? So similarly, acoustic anomaly detection in fab equipment. See, when we have this fab equipment, it may malfunction, right? And sometimes malfunctioning equipment will produce some sort of a noise. And from that noise, we may be able to sort of tell that there is a problem. Right? I believe it has also been done for things like transformers and things like that. Right? So anomaly detection and maybe even diagnosis based on the noise that is being. So it's a signal processing kind of a problem, right? But machine learning is important because we don't want to flag something which is not really an anomaly as an anomaly. So people are using to use, and you can also do predictive equipment maintenance because these equipment are very expensive, right? If there is a downtime, see suddenly if one of the machines develops a problem and it goes down, you see the whole fab will, the assembly line will come to a halt, and that may result in a lot of loss for the company. So you may want to use machine learning to do this predictive equipment maintenance. Keep observing various parameters that you can collect using sensors, temperature, and so on, and then sort of use machine learning to predict, whether this particular equipment is developing some sort of a fault. Now let us talk a little bit about quality. I think I have mentioned to you what quality is: defective parts per million, or TPPM or DPM. And DPPM will be fractional in case of automotive, right? Or DPPB, where B means defective parts per billion. And unfortunately, a defect may not always cause a fault. So there could be a latent defect which does not become a fault per se at this point of time. It may become a problem later. See, that is a hard part. It will pass your test, okay? But at the when it is used, it may develop into a full-fledged fault. Okay. So, for example, maybe the part draws more current. Okay. But we don't measure that, right? It's fine. I mean, there is no stuck at fault or delay fault, but unfortunately, the current it is consuming from the supply is large. Okay. It may not be, I mean, if I only look at it as a fault, the chip is not faulty. But when I release it to the customer, it may become a reliability issue and it may fail within the warranty period. So that is an issue as well. And, to you how testing has usually got, fault-oriented testing. We always generate tests for specific faults, right? But today, some people do talk about defect-oriented testing. Okay? That means instead of targeting faults, can we target defects? So I hope the distinction between defect and fault is known now. A fault is something. See, take an inverter. Okay. If the output of the inverter is always stuck at 1, right, that is a fault. But why is it wrong? Is it because of the PMOS transistor being always on, right? The PMOS transistor may have stuck at close kind of a problem. That means the transistor is always on. And why is it always on? It may be because there may be some, it may be there may be a short there in the ground and the gate. Right? So we don't know what the defect is, right? But effectively, it appears that the output of the inverter is stuck at 1. So if you are interested only in the fault mechanism, stuck at 1 is the fault. But if you go deep into the device and understand what is the defect which is causing it, is it a short circuit? Is it an open circuit? Is it some charges that are trapped in that gate? What is the reason? Then it becomes a defect. Yeah. So typically, people have done what is called as there is a concept of meaning. See, suppose there are totally about 1 million possible faults that can occur in a particular chip. Ideally, I would like to test each one of them, but maybe for whatever reason, I'm not able to test for all the 1 million. Right? I told you that it is very expensive if you want to generate a huge number of tests to cover every fault. You have to be prudent also. So suppose I may only end up covering 99% of them. Then the test coverage is 99%, right? And that test coverage is able to cover things like shorts induced by dust particles, okay, or if there is a mask misalignment causing some geometry to be malformed, okay. These kind of things are easily detected by that 99% or whatever test fault coverage. Right? It may also, but now we have to also talk about in-field test coverage. So production test coverage versus in-field test coverage. So in-field test coverage is important because today we can also have faults coming because of various electrical stresses that may be there, wear out mechanisms, aging, and things like that. Okay? So we talk about what is called as a single point fault metric, SP. Okay. Now, what is an SPFM? An SPFM is a fault in an element that is not covered by a safety mechanism. See, remember that I talked about this fault tolerance earlier. So there you may have built in a safety mechanism to protect you in the case of a fault occurring. Okay. See, for example, you may have heard about error correction codes, right? So even if there is a let us say 1-bit error in the memory, the error correction code is masking that problem, right? But if there is a SPFM, that single point fault, unfortunately there is no mechanism to catch it. Okay, so that is the difference between a defect and a SPF. Defect means a defect, right? When it is being, when it is manufactured, we are trying to test such that there are no defects, right? SPF means when it is being used, at that point something went aging. It may have developed a fault. So this is something that you have to address through design. It cannot be addressed through test. Okay? So that is the difference. Now let us come to a little bit about security, right? I told you about how, in addition to uh, defects that may arise in chips or aging and other phenomena, reliability phenomena that may occur, What is unfortunate is that today our chips are also, they can be under attack by malicious people with malicious intent. Okay, so unfortunately, there are lots of ways that they can attack, and why are they doing it? Because they may want to steal money. For example, here is a way to steal service, electricity. Okay. So there is an electricity meter, okay, and you want to hack into it so that you steal electricity, okay, or maybe you can get free television service by hacking into some set-top box or something like that, or you can steal data from credit card, right? So these are all the reasons why you may. Or people may be trying to steal the IP, right? There may be some software, and you are trying to read the software. You are trying to steal that code. Okay? See, steal some trade secrets or ID, right? And you may also be interested in producing fake copies of that. Okay. You may also service. Okay, maybe you have a server. Okay, maybe you have set up some sort of a server. You have a small company and some sort of a shop, right? Online shop, right? Now maybe somebody wants to disrupt your service, right? By sending you fake requests. Okay, so your server is sort of busy answering a lot of these fake requests, and they are being sent by a machine. They are not being sent by real people. Okay, let us take Amazon for example, right? All of you use Amazon, Flipkart, and so on. So imagine that I could, send fake orders to Amazon, a large number of them, right? And while it is busy processing those useless orders, at the end it will all be cancelled, right? Real customers are not able to get any service from Amazon. Okay, so that is called the denial of service attack, and it can be a loss of revenue for Amazon. And every year, these attacks happen on all these companies like Amazon, Flipkart, and so on, right? And it has become a very routine thing now. There are companies which are into this as a business, doing this denial of service attack, etc. Big companies like Amazon can at least afford to put a lot of manpower behind this and IT services to watch out. But small vendors can actually be in big trouble because they can't afford to do this, right? Last but not the least, what if you can start controlling, like I told you the example of the car, right? I mean, you take over the car remotely, or maybe the heating system in a house, right? In India, I don't think anybody will die if there is no heating inside, but there are countries where the winters are very cold, and if there is no heating, maybe people are going to die, right? So imagine, there is a big apartment building, and suddenly somebody has taken over the heating of that apartment building, and there is no heat being provided there, right? Or in the worst case, what about a nuclear reactor or something like that, right? These are all horror stories, right? That we really don't want them to come true, right? So how are attacks being done on hardware, right? So there are many ways people do what is called as micro probing. Okay, so they will buy your chip, right, and they will sort of reverse engineer it, right? They may even use acids, etc., to remove the various layers, and then examine under microscope, right? That stuff is called micro probing. reverse engineer both the hardware and the software. Right? Then there is something called as fault injection. You can inject faults so that your chip doesn't work. Right? I will explain that a little bit later. Right? And then there are what are called channel attacks. I think I have explained it later. Right? And finally, there could be steganography. Right? Uh, the chip, also includes, hidden data. Okay, along with the data that is being sent, there is also some, few bits here and there stuffed into the real data. But somebody who knows how to put it apart, you will be able to see the hidden messages. See, for example, what if you want to send away some trade secrets? See, maybe you are a mole, right? You are a bad employee who really you joined that company only to get some trade secrets, right? See, you cannot openly send that secret, right? Because you will be caught. You can use this steganography. So all these are things that people are worried about, and the ones who are really worried about this are the defense organizations. So, for example, the U.S. Department of Defense is very worried about these hardware security attacks, and as a result, there is a lot of funded research today in the US in these areas like hardware security. Because imagine if Department of Defense has purchased some equipment, ICs, etc., and they can be controlled from somewhere else, right? You may know, right? I mean, there was this guy called Dick Cheney who was, I think, part of the Bush administration. So he was, and he once asked, that all the see he wears this pacemaker device, right? And imagine that somebody can cause a fault in the pacemaker. It may stop his heart, right? So it may. So he had asked, special care to be taken so that all the communication is stopped. No wireless communication to happen between the pacemaker and any other. Okay. So like this, right? Um, See, the attacker may want to cause malfunctioning of a CPU, or the attacker may force program something into the memory, or he may read the data in the memory. Okay. Or if it's an circuit, he may cause something like, let us say, the pulse width modulation output to be programmed, incorrectly, so that the control is going to go haywire. See, the PWM output may be controlling the speed of some motor, right? By controlling this analog and causing a fault there, the speed of the motor can be made very low or very high, right? And as a result, something bad can be done, right? So normally, people don't worry about this. See, normally when I write a program, right? Unfortunately, I don't assume that the CPU which is executing this program or the memory that I'm writing into has a problem, right? Software is already quite challenging. Right? Imagine if you have to write the software which assumes that there can be these difficulties. So as a result, people are trying to, come up with this is a research area now where this hardware should not be it should not run everything. It should not run all software. It should not forward all packets. It should not respect every request that is coming. Instead, it should have some self-awareness. See, just like human beings, they have this so-called sixth sense, isn't it? Um, See, we can, if you meet some stranger and the stranger is, asking you something, and you can make out something, if something is not right, right, and you will refuse to provide that service to that person, right? So in the same way, the CPU must possibly have a sixth sense. So that is what these are all sort of research areas. And the problem is quite large. The size of the problem is large. So because the modern cars may have as many as 100 electronic control units, right? For all things like engine control, powertrain control, okay, all kinds of control. And may also be having advanced driver assistance systems, or let us say parking, for alerting drivers about any obstacles on the way and things like that, right? And there may be vehicle to vehicle connectivity, right? Ability for vehicles to warn each other of problems on the way, right? If somebody you can see, it can be huge impact. So there are some standards that have come for safety and reliability. So there is a big standard for automotives called as ISO 26262, right? And from a supplier point of view, if you are going to join a company that works on automotive electronics, you will hear of this particular term called ASIL, or Automotive Safety Integrity Level. And have 4 levels, A, B, C, and D, right? And I will tell you a little bit more about them, and you have to maintain that standard. So what is ACLA? ACLA means, an example is given here. If a car's both the rear lights fail, okay, it's an ACLA defect. Okay. So any electronics that controls the two rear lights, if for some reason, if because of some safety issue, aging and things like that, if both the rear lights fail, if a fault occurs, that is classified as an ACLA defect. What if there is an incorrect sensor feedback, or both the headlights fail? That is more serious. So called ACLB. Or brake failure, etc. So these are more serious because it can be bad, right? What about unintended brakes? This is definitely very serious. Right? Suddenly, you did not brake the car, but suddenly it is braking. Or unintended acceleration, unintended start, or the suspension begins to oscillate. So these are very, very serious. And finally, if suddenly the steering is going haywire, or unintended, see, this is both again. So these are all. So when you supply parts to your car manufacturers, right, they may ask you to stick to these standards, and adequate testing will have to be carried out to make sure that it meets ACLA standard or B or C or D, right? So how do we achieve that ACL compliance, right? The verification also has to be high effort. Okay. What is verification? How is it different from testing? The verification is what we do at the early stage, even before you manufacture, right? So you want to know whether there is a bug in your software or a bug in your hardware, right? So you do a lot of functional verification to avoid ending up, with some functional bugs in the hardware. So the effort in verification has to be very high in order to achieve ACL compliance. Similarly, you may want to provide some redundancy in the hardware, especially when it comes to critical components, so that there are no such faults. Or even if the fault exists, it is masked, right? I already told you about error correction and detection, ECC memories. Similarly, there is something called a CRC, right? Cyclic redundancy codes. So that's also a way to check for faults and detect the presence of faults. And I think I have mentioned to you what built-in self-test is. Similarly, inclusion of watchdog timers in microcontrollers. That is an important way to figure out that there is something wrong. Suddenly, your maybe your microcontroller has gone into a hang state, right? It's not responding to any interrupts. So in such a situation, the watchdog timer will ultimately kick in, right? After when after a sufficient amount of gap, the watchdog timer will reset the system and again get back control, right? So, and nowadays, even for security, right, they are trying to come up with some standards, right? So these are really new, right? And these are all hot areas of research and development today. So the fail safe and fault tolerance are extremely important to the industry, right? Because I told you, right? I mean, it is like a one of the things on the Internet of Things, right? It is connected to the internet so that people can track it, right? Maybe you are running a fleet of cars, maybe you are Uber, right? And you are running a fleet of cars, or maybe maybe when you left your today, when you are driving, your family members may like to call you to see where you are, right? But suppose you have lost complete charge in your phone and you are not traceable or something like that, they may naturally get concerned, right? So maybe you can track where you are, right? There is enough intelligence today available to track this particular car, right? So the car is sort of through a lot of sensors that may be there in the car, right? A lot of data may be coming in, gets frequently uploaded to the cloud, right? To the servers, right? And here is where a lot of analytics are being done, okay? In order to track the car or in order to find whether the car is going at a very high speed, right? See, Uber may be interested in finding out if there is a driver who is driving too fast, okay, and warn the driver that you are going too fast, right? So they may have a sensor to measure the speed of the car, and it is detected somewhere here, and a message is sent back to the car, right? So this is how things. But the problem is, when you do everything here, right? All the analytics, it is not very great because it increases the data rate very significantly. A lot of data being sent frequently, right? So the data rate becomes very high. The power dissipation becomes very high, right? And also security can be a problem, right? What if somebody can manipulate the data that is being sent, right? That can also. So in order to cut down some of these things, people try to use some sort of edge. Let us put some logo and everything there. In the trunk of the car, there is some device out there. Okay, this cloud is instead of this server here, there's a small server here, right? And the problem with this is it's going to be quite expensive to do this, right? I mean, you have to put a whole big compute server or a computing engine here, right? So these are all expensive propositions, right? So both in terms of the cost, power, and maybe even security, right? So people are trying to come up with alternates. So these are the of the research for those of you who are interested in research topics, right? I think I have mentioned this to you, what denial of service attack, etc. So if you look at the car here, right? Here, right, which is providing whether cars are going too fast or provide the location of the car and track it, etc. So you can cause a denial of service attack there, right? As a result, suddenly we are not able to track things. We are not able to find out if cars are going too fast and things like that, right? How will that attack be caused? By providing a lot of fake information to the server, right? As a result, real-time responses will no more be possible. Similarly, there may be gateways through which this information is coming, right? So somebody may take over the gateway and send false data. And that gateway, itself may be connected to transceivers and sensors. And people may try to either steal information from the sensor, prevent transmission of data, or gain control of some computers. All kinds of attacks are possible. And see, the data that we sort of put into our chips, right? We have to guard our customers against somebody trying to steal that data, right? So there is something called as JTAG, right? I hope you know what JTAG is, Joint Test Action Group. So it is typically used for debugging. It is typically used for sending test data and reading test data back from a device. Okay. So unfortunately, a malicious application can use this JTAG to read sensitive information. Right? Maybe they will read the encryption key of the some encryption algorithm or something like that. So as a result, today this is exactly what is a side channel attack. So this is called as a side channel attack. So people are trying to protect JTAG with a password, right? And there is also a fuse that is provided with the JTAG port, so that you can prevent JTAG ports from being used after when you are releasing the part to the customer. You just remove that fuse so that nobody can use the JTAG port. Or maybe if somebody is trying to repeatedly try to read data by providing various passwords. Passwords, right? So maybe you can erase the FRAM because you detect that somebody is trying to steal data. So this is another security feature that is included. Or maybe if you have an interrupt vector table, see normally there could be about let us say scope for 64 entries in the interrupt vector table, but you may only have 35 of them. Okay, the remaining entries are usually left for nothing is stored in them. Okay, that can be dangerous. It can be used by some attacker in a clever way, cause an interrupt, which is going to lead you to some interrupt service routine that is going to send all the data and things like that. So as a result, you should not have any invalid entry in the interrupt vector table, even if the interrupt is not used. Interrupt vector table. And when you're trying to do any firmware change, occasionally we may provide a new set of firmware to our customer, and he may be trying to change it. At that time, you make sure that the JTAG is not functioning, or the boundary scan is not functioning, so that nobody is stealing any data during So this is what I was trying to explain. So this is our JTAG. Okay. So JTAG requires a test data in and a test data out. So you can use this to read data from the device or write data to the device for test purposes, right? So somebody can use this to read away some, you know, here which may have the, some password or something like that, and they may want to read it off. Right? So that is why they are using a password fuse. And if you burn this fuse, nobody. So test mode signal cannot be used anymore. So these are all various mechanisms that people are now trying to put in. Okay? They are also trying to do a few other. See, if you do this method, right? But maybe it is overprotection, right? You will not be able to selectively say, protect a particular IP. Okay? So for this, they have thought of this IP encapsulation. Okay? So there is, the concept of a secure zone. Okay, in your memory. Okay, here is a IP which is protected. Secure zone 0. Secure zone 1. These refer to code, software code, which is available in different parts of the memory. So the idea is in this here you cannot use JTAG at all, right? If there is no, uh, you know, if you burn this fuse, nobody JTAG can never be used. Okay? But here there is a, you know, some little bit of respite. Okay, you can say, first of all, what secure zone is one where the software is only meant for execution. It should not be read out from. See, I may be trying to steal this code, right? I want to read what is there in that code, right? So that should not be permitted. This code can be executed, but it should not be read out to an output port. Okay? So if you want feature, it's called as a secure zone. Okay? And you when right, we don't want any debugging to be occurring, because doing debugging you can read out the data. Right? So you can allow JTAG based debugging. Okay. So while you are trying to execute this software, it is okay to debug some other. So this will allow, some concurrence. Okay. So in this device, this solution does not possible. Okay. People are also trying to be too clever by using things like microscopy, atomic force microscopy, etc. By doing this, they can sense the small amount of charge inside the memory. Right? See, remember the RAM consists of a number of flip-flops, and those flip-flops basically, that SRAM cell has a small charge to represent a 0 or a 1. So imagine that you can remove the cap of the chip and then start doing some microscopy, and you can start detecting the amount of charge. You can actually read the entire the contents of the RAM. Okay, so that can be a problem. So people have to design their chips now to prevent this kind of a thing from happening, right? I think one way is, in some of these technologies like FRAM, there is a ferroelectric RAM. There, if you try to remove the lid, then it will simply not functioning. So as a result, anybody tries to remove the lid, the whole charge will be lost and it will not function. People are also trying to use fault injection attacks, right? So try to manipulate the voltage or a temperature or clock in order to cause a fault. right? You have to really know what the the hardware and the software really well, okay? And the fault may cause a bit to go from 0 to 1 or 1 to 0, and as a result, the whole instruction gets. See, as you know, when you encode an instruction in a computer, it is a series of zeros and ones, and if I change 1 0 to a 1, the whole instruction meaning can change. And sometimes, I may have an if then else statement, right? And I perform a, I'm doing something only if there is a condition, if that condition is true. But if I manipulate that bit somehow, then that if part is not going to work at all. Okay, and as a result, an important instruction may never be done. Okay. And that may help the attacker to either control something in your device or read some data from the device and things like that. So these are all fault injection attacks. So today, if you want to design a secure processor, okay, all kinds of things may be required. You may have to include various encryption engines like AES and SHA in order to protect the data, right? You may include a password check, right? You may need a ROM, because ROM is not right? Or you need, so you can see that in this architecture, many things are being done only to protect the it has it result in extra area, etc. But unfortunately, such a thing cannot be avoided if you really want a complete, secure device. Okay. And there is also a need to verify. See, I told you what verification is, right? So verification means to check whether the hardware does what it is supposed to do, right? But what if it does more than what it is supposed to do, right? It may be a hardware Trojan, which occasionally sends data or something like that, right? Or causes some malfunctioning, right? So a security vulnerability may be triggered, right, by a fairly complex sequence of events. Okay. See, the person who put the Trojan is not a fool, right? He would have manipulated that after a very long time. After a sequence of events occur, then that hardware Trojan wakes up. Okay. Now, when I am verifying, unfortunately, I had to think of so many different, possibilities if I want to see whether a Trojan is present or not. Okay. So people are trying to come up with what are called as security rules. Okay. So I think this animation didn't work. So this is an example of a rule. Okay. Is a company which is enhancing the this verification through these kind of rules. So this is a security rule. It says that the rule will fail if any signal from this left hand side will flow into any signal on the right hand side. Okay. So this rule is simply saying that there should be no path for a signal from here to a signal from here. Okay. So it may look like this. Okay. So if you join as a verification engineer who works on automotive parts, etc., you may end up using these kind of security rules, right? And the software will then verify whether something like this is possible, right? So this verification flow is going to look like this, right? So you will have to include security also into the you'll have to write separate security rules in addition to normal rules that you write during verification. Okay? And they have to be simulated, and we have to show whether there is a security breach or not. Okay. I have 10 minutes to complete. What I do is, let me see if I need to skip some things, because I do want to have. Okay. So there is a new test fault method called as cell-aware testing. I'm going to skip this right now. I'll briefly tell you about adaptive testing. See, adaptive testing means, it's the example of the airport screening is a good one. In the airport you may have gone through security screening, right? Each and every person. Unfortunately, if you do too much of screening, people will complain. Okay, the same is true in the semiconductor also. So there they also use some intelligent profiling, right? What they try to see is that person, what kind of company is he keeping, right? If that may give them a clue as to whether they must call them for closer security. You may have seen in the airports, they pick a few people for detailed screening. How do they do that, right? They may have they are applying some rules, right? In the same way, here maybe if you take this wafer, see here there are a lot of faults, right? This particular green one, it has no faults, but look, it is very close to these devices, which are, they have a lot of faults in them, right? So maybe we should screen these more thoroughly than, let us say, these ones. Okay, so that's an example of adaptive testing. More detailed screening for some of them, and quick screening for the remaining ones, right? Like in the airport. So if you use those kind of things to reduce the amount of effort, it is known as adaptive testing. So looking at the neighborhood and looking at outliers, right? So if your a parameter that analog parameter that you are measuring, if you see a anomaly, right, then it may have a reliability issue, even though there may be no fault as such. So you may want to do some outlier screening, right? In order to do this adaptive test control, which is a good thing to do because it reduces the total test effort, you may have to sort of have a way to track the device, right? See, here is a wafer probing that we are doing, right? And then it will go to pre-package testing, post-package testing, post-burn-in testing, and finally in-system testing. So if we have to track this data throughout, then we need this some very rich database is required, right? Which can remember everything, right? So for that, they use this RITDB, right? Rich Interactive Test Database. Okay, this has become a big thing these days in semiconductor companies. So the intent here is to provide a standard approach to test data collection, right? I don't think I want to spend too much time because I'm running out of time. So I have 7 minutes left. So I'll start concluding now. Basically, the whole summary of this presentation is that today testing and verification have become a lot more complicated, right? As you may have realized during my presentation, thanks to three concerns. One is quality, the other is functional safety, and the third is reliability, right? So test engineers are therefore, they have a lot more responsibilities on their shoulders. And many of you may not know, as students, you must realize that it's a big career path. See, many people don't understand this. They always think that design is the main thing. So they always ask for design roles. But test roles are much more challenging and harder to fill also. If you have those who become good in these areas, design for test, design for reliability, functional safety, etc., they are always their jobs are very secure and so on, so they are always in demand. You will realize that companies are struggling to find people in these areas of expertise, right? So verification and test are very important from a job perspective also. So don't ignore that aspect, right? I think I should stop now and take at least a few questions so that you all get a chance to talk because I have been talking a lot. So, any questions at this point? I have at least 6 minutes for Q&A. I would love to have some questions. Any questions?
Hello, sir.
Yeah.
Yes, sir. So, as you were talking about the roles in testing, as students,
Yeah.
kind of like what kind of topics should we study, and on what
Yeah. Yeah.
for that?
See, when companies hire for the role of testing, right?
Yes.
It will be great if you come with some background, but if you are an undergraduate, right, who is joining, I think the background that you should have is you should have taken a course in digital electronics, analog electronics. They can give you some training on test related things. See, when you become a test engineer, the skills that you will require, right? One of them is design for test. Okay, how to insert scan chains, how to insert built-in self-test, how to insert JTAG. See, that is a very specific skill, right? Similarly, functional safety. I'm not sure whether everything can be taught in a college. It will be great if you have a course on test and testability. So when I was a professor in IIT Delhi, I used to teach that course, testing and testability. But I know that it's not always possible to have that course, right? Sometimes what happens is people are not very keen to take a course on test because they think it's a very dry subject or something like that. But not at all true. I hope I was able to give you a glimpse of how many interesting problems are there in the area of test, whether it is design for test or security.
Yes,
So these are all very interesting areas. So you, yeah, go ahead. Please, understand that when you get the opportunity to work in the area of test, reliability, etc., come with an open mind, right? Don't be under the impression that only design activities are interesting and test activities are not interesting, right? So there is a lot of uh, career opportunities in the area of verification, test, validation. Yeah. Any other questions?
Sorry, sir. I
Any
just
other?
got it.
I could not hear the question. You are welcome to put it in the chat box also because I can see your chat. Okay. So if there are no questions, I think I will stop now, and I will conclude by thanking the organizing committee of INDICON 2020 for giving me this opportunity, and also the panel of hosts and panelists who are there to help me throughout the presentation. So thank you very much. I hope you found something interesting and learned something interesting. Thank you.
Sir, on behalf of everyone present here at INDICON 2020, I would like to thank you for your insights today and for taking time out to share this captivating information with us. It will surely help us all to develop greater appreciation for the new endeavors in semiconductor verification and test in modern times. Thank you, sir.
Thank you. Thank you very much.